So this is the presentation.
You don't read last time? What did you do last
This is how it started. Then this is the vision, and now we have the these are the workshops and skill trees, and that's it. So we have workshops and skill trees. We have this one, but otherwise we have free bootcamps around the world, and that's how it developed.
Okay, then you can do the intro and.
Should I do the entire presentation? What do you mean?
So. Let's figure out if. Okay, then we'll wait now for like 5 minutes for toilet break. One question, is this loud enough or should we use microphones or is it okay? Is everybody approximately ready? Then we can start. Yay. Okay. Hi everyone. We are also live streaming this because we have like some friends from wherever watching us. So hello also people from far. We are in beautiful Pun Space, who is our event sponsor today. So they gave us this beautiful location for free. So thank you, Pun Space. And we are WizardAmigos, basically open source volunteering community that teaches coding and basically the literacy of the future. And we started in Berlin, and we have like some amigos in Taiwan also. Nora is one of the organizers there. And this year we decided to meet in Chiang Mai and to make like a month of coding camp. So we're meeting every day in Maya, coding, and then once a week we also do these kind of like sessions where we do like workshops and talks. So today we will have CoolBitX presenting the Cool Wallet and their SDK, and then the Solidity workshop. So Alex will do like a little intro about the WizardAmigos, and then we continue with Nora. So thank you all for coming.
All right. So maybe very quickly. So maybe we started around 2013 because we felt like we want to be more independent, and we want to find like-minded people to work together and be self-organized. I mean, that was kind of the initial idea. It was still very fuzzy. And what we did is, in order to get more people who were interested into the same stack, we used the opportunity that we had a project to build like an e-learning app for a little election campaign in Serbia. We were approached to build them some app. But the cool thing is they allowed it to be open source because they don't needed it after they finished their election campaign. So we could reuse this. And there was a nice opportunity in 2015 when we had already our little regular meetup. And a lot of refugees came to Germany because that's where we started. And we were thinking, oh, all these people might want to meet locals and somehow want to get in touch. So maybe why wouldn't we help them? And we built a little platform called Refugees Work, which was basically a way for them to reach out and find volunteering or little job opportunities. Because if you have something to do, you can get in touch with people and talk at least about the thing that you do. And that's what we were thinking as developers. That's what we can maybe contribute. And in the same time, we figured out, a lot of jobs or volunteering opportunities have to do with something that is IT related. So many of them didn't have those kind of skills from their backgrounds. We thought, let's reuse the open source platform that we already built and also teach them coding and use them in our to help them, and maybe they would join the community that we already had, which worked out quite well. But while we were discussing, we figured out many of them are not just refugees fleeing the war. They are also coming because of a better economic opportunity, which is totally understandable, because why would you stay in a fucked up environment if you have maybe some better chances elsewhere? But so families chip in lots of money and they take lots of risk just to make it. But in our times, actually, the majority of people are anyway already knowledge workers. So they literally sit in front of the computer and work and do it in the office. But many of those jobs could actually be done remote. So if they had the right skills and knew programming or any other digital professions, they might be able to work and earn the income remote without leaving and taking on dangerous journeys. So we thought, if that's the case, and we are already working remote, maybe we should take the opportunity and go elsewhere and help people where they are. So that's when we started traveling and trying to work remote. And every time we came somewhere, we didn't just want to be tourists, because that's every time the same experience and people want to sell you souvenirs. So how do you get in touch with locals? Maybe while we work, we can also organize either some meetups or events and actually teach a little bit on the side. And eventually we find people who are like-minded and they join us, and then we can actually make friends and learn a little bit about the local environment in which we then are at that moment. And that worked out quite well. And over time we grew like a lot of events with people that we're still in touch with, and they're kind of distributed all over the world. And surprisingly, many of them continue to meet and do stuff together, even though we're not there anymore and they're completely independent. We actually have nothing to do with this. So they just do this all on their own, and they decide how they do this. But yeah, so basically this is what we're also trying to do here. So we started 3 years ago to make once a year like a code camp. It's always free. We choose a location and then we just do this for 1 month. And this time it's in Chiang Mai, and we invite anyone who feels like called to join and listen, or maybe even contribute and present their stuff. So we also have mentors that join and they just teach. And so in order to make because in the long run, if there's enough people that work remote, we would actually like to work together. Like usually there's a lot of people that freelance, but they work for companies and they always work for the same company. And if they come somewhere, they might work remote, but they don't really, like if you meet them in a cafe and you say, hey, we have this cool idea, they're not really entrepreneurial, and you can't really convince them to do anything, because next day they have to again work for the same company that they just work remote. So if we have a community of enough people who are skilled, maybe we can even join and have together some entrepreneurial projects. I mean, it's still a long way to that, but I mean, that was kind of the idea. And in order to keep the teaching going while we're maybe not doing a code camp, we also built some software. So we this initial software that we once had, we improved it and thought, how can we make that more like, not like a platform where everybody can do it, but like more people can do it themselves. So what we had in mind, we want to have like a giant, let's call it skill tree. Many people are familiar from games, where people actually can just learn one thing and then go to the next and learn the next thing, basically like a curriculum. But instead of having like one university or some teacher or organization that does plan the entire curriculum, why not making that peer-to-peer? Everybody knows something and they can publish this as a workshop. And if somebody else does a different workshop and figures out, oh, I want to make a front-end workshop, but I need some design. But there's a designer that already made like a design workshop. So maybe I can, instead recreating a design workshop, I say, hey, this is the dependency. You should learn that design workshop first, and then you have the knowledge to do the next one. The same one could be with trading. Maybe you already want to learn trading, or you want to do smart contracts, or you want to do a combination. Maybe you need to have trading knowledge and smart contract knowledge. So, but not one person needs to do all these workshops. Everybody can contribute something. And we created like a little workshop module. The way it works is we have like some tutorials too, but what it does is essentially you fill out one file, that's a data file, and you can have like a little form. It's currently work in progress. But that form, when you click the publish button, you get a workshop that looks like this. This is just a preview. It's still work in progress. But behind the scenes, that form generates a single file that looks like this. It basically, the different elements are like a data entry for the title of the workshop. There are different themes for the same thing, for the same workshop. That's one of the themes now, a demo theme. There's an entry for an icon, so the workshop can have an icon. There's a chat link, so there can be a chat integrated, like a support chat. If you're stuck in the workshop, you can basically chat and ask for help. And like the people who are already in touch with us for a longer time, they usually hang out on the chat and can give support. The same that we would otherwise do in person if there was a code camp going on. And then you basically have like a list of lessons, which have each a title, a resource, which can be a video, a PDF, a slide deck, whatever people create their content in, and a little bit description. And then on top of this, they can also specify a tool. So if you want to teach design, you would maybe use an embedded tool in the web to design. Or if it's coding, depends on if it's front-end coding, or in this case, it's smart contracts, it's a solidity language. There are basically tools for all kinds of stuff on the web already. So even big companies like Adobe put their tools into the web, and Microsoft does. Google Docs is in there, so you could teach the Google Docs spreadsheets. Probably even the trading tools are in the browser, so you could do that too. And that's kind of the idea. So if enough people create those workshops, and by now we have quite a bunch of them, then the next ingredient, like we have many people who created workshops with different themes, the next ingredient is that you have a skill tree, the one that I mentioned initially. So one final thing in that file that you also create is you can specify a bunch of workshops as prerequisites and a bunch of workshops as one that you recommend to do after. Those can be done also by you, but it can be done by other people. Doesn't matter. And what comes from this is basically the entire skill tree. So you can see all the lessons and you can click on any of them to open the workshop and learn. And now what we're currently trying to solve is we want to have a list of tasks. They are initially exercises. So like something simple to get started. And we are having an organization, they're called Gitcoin. They're giving little bounties, and they even support us to say once we integrate enough of those exercise tasks, they would even chip in a little bit of money to support people to earn while they learn. So for example, we were last year or the year before, we were in Phuket, which is also Thailand. And we were every day eating in a Buddhist place because we are vegans and they cook vegan food. So that worked out for us. But over time, we got to know the people and we figured out, oh, they wake up at like 6 o'clock in the morning and they prepare everything. Then they drive and they cook all day long and clean. And at around 8 or 9 in the evening, they finish. So they close the shop, but then they go home and wash and clean everything. And then like at around 10, 11, they basically drop into their bed and sleep. But then the next day, everything repeats. And in between, they have a little daughter that is in the shop. She walks around, but they barely have time. So she has some toys and they kind of try to manage her in between. But actually, we figured out from calculating and interviewing them over this 1 month that approximately per day, they earn like $50. So, but from this also, they have to pay the costs. So that's actually so little, and they are so busy and they have to pay their bills that they could never afford to switch the profession. But $50 is also so little that it's maybe those little bounties, they will not help somebody who lives in Europe or the US or anywhere and earns like a decent income. But $50 a day, this is enough to cover, to help them that they can try to learn and transition. And so those kind of bounties and for exercises would be interesting to help them switch and try out programming. And if they like it, they might switch their career. But otherwise, we also work with people and already pay them remote, and we try to get more people into this. And the idea with this workshop, so if we have a skill tree with all these people and they all made their little content like to teach something, and we have this skill tree, then anybody, whether them or clients that anybody brings into this ecosystem, could take that project, break it down into multiple steps, and put those as tasks on the workshops that teach the required knowledge. So somebody who's learning can explore, where do I get the right kind of jobs that pay me, and already see it, and then basically find the jobs that match their skill set. So that's kind of the idea where we would love to bring this in the long run, so that if the skill tree is big enough, all the real world tasks can be matched to the right skills, and the people who learn and the community around those workshops that maintain them, they could solve those tasks. Now the thing is, I showed this one before, this is basically part of the workshop where the people who maintain the workshop can decide how many percentages of each solved bounty or task will go to the workshop maintainers. So if there's a task that pays like $100, then maybe 13% or maybe 3% would go to the workshop maintainers for every solved task, which funds them to maintain the resources and keep them up to date. And they can also split that between many contributors, and they can also split that between their prerequisites. So if I'm teaching something, but I use 3 other workshops as prerequisites, maybe I can say I pass on a little share to them too, because they helped bringing people to the level where they can actually do my workshop and then actually solve the task, which brings me the income. So this is another part of this, so that basically this trickles down and makes it sustainable. Right, so that's basically the idea behind WizardAmigos, but of course we're still far from having this like working flawlessly. It's just like a vision, and that's what I wanted to share. And now maybe we can continue with the rest. So that's just a small introduction.
I'm now thinking these motorbikes and stuff, should we move closer so that, or are you hearing well? Because, yeah, it's okay? Because for me it was like, constantly, no, it worked. Okay, so Nora, please tell us more about the CoolBit, and maybe you can, I can put it for you here. See? Oh, you lost this. Just a second. Cool.
I'm not sure if I can be loud enough. Is this okay? Okay. Okay. Right. So, okay. Let's get started. So my topic is CoolBitX and token swap on 0x protocol. A brief introduction about me. I'm a React Native developer at CoolBitX. So it's about more than 1 year ago, our company decided to use React Native to develop our app. So React Native is a class platform framework for develop mobile apps. It can be write one code and use everywhere. So token swap is also written in React Native. So about CoolBitX, CoolBitX is a fintech and blockchain company based in Taipei since 2014. Our products are hardware wallet, mobile payment, and other blockchain applications. Okay. So CoolBitX is a card. It's a hardware wallet that offers offline security, convenience, and mobility. It has secure element, Bluetooth encryption, biometric checks, and advanced seed recovery features. Also, its forward-thinking dimensions and patented compression technology makes it tamper-proof and also waterproof. So I will play a short video about CoolBitX. So that's the introduction video. Okay. So we have 35% discount for developers. So if anyone is interested in, please let us know. Okay. Okay. So for our CoolBitX app for CoolBitX, it can be paired with both iOS and Android device. Both its firmware and app is constantly updated to proactively defend against security threats like phishing attacks. So the CoolBitX currently offers native support for cryptocurrencies like Bitcoin, Ethereum, Litecoin, Ripple, and so on. As for features, apart from send and receive, we also have change lead and token swap for exchange. Introducing Wallet Connect, it's a way for web dApps to interact with our mobile app. Basically, you scan the QR code on web dApp, and then so you can choose your address and then connect to the web dApp. So you can do transaction on web but use our hardware wallet. So this is the main feature I like to introduce to everyone today. It's token swap. It's still beta. It's a beta feature right now. So let me start with token swap. It's a decentralized exchange feature based on 0x protocol, which allows users to exchange tokens through QR code. So there are two main users flows for maker and taker. We will be hoping for feedbacks later if anyone wants to try to use this feature. And then this is a video for 0x protocol. I think it has a clear story for introducing what is 0x. Okay, let me play this video.
So we should make a deal. To make a deal, we come to the table. The problem is the table belongs to someone else. So when we sit at their table, a middleman controls the process, holds our valuables, and charges us a lot of money. It's risky, slow, and expensive. What would it look like if this weren't just a table, but a network? A network that no one owns and can trade directly with each other without anyone to pay. Enter 0x. 0x is a decentralized exchange protocol. It's a set of rules that businesses and developers use to create a network of exchange that no one controls. 0x, anyone can come to the table. This means that if I'm going to trade my currency for your currency without anyone else, I can do that. Or if I'm going to trade my currency for some real estate, I can do that too. I can trade anything for anyone, with anyone. See, 0x isn't just about charts. orders. It's about the exchange of value. Developers can use 0x to create marketplaces for the entire world of assets. Holistically, they can create markets for your favorite needs, or for digital commodities like storage or computing power, even digital art and collectibles. The 0x protocol is open source and governed by its users, removing all geographic barriers and opening the door to markets that can enter existing equal. It won't be possible thanks to 0x. Come to the table.
So that's 0x. So I will explain a little bit. This is from their white paper. How it works in a high level is to define the orders that you want to make, and like order parameters, tokens you want to trade, also the exchange rate. So the counterparty and how long this order will expire. And then take all this data signed with your private key, and then you do all this off the blockchain. So it doesn't require transaction at this place. And you show this deal to your counterparty. If they're happy with the rate and device to fill the order, they will take the data and cryptographical signature is authentic, and order has not expired, and both parties have sufficient funds to finish the trade. The smart contract will then move the funds between the two counterparties. Okay, so for the order message format, this is the basic order message. The key value you need to put in, like maker address and taker address. Also, maker asset data. Maker asset data contains all the identifying information about the assets the order maker is trying to sell. And so you can see the right side is the simple code for the data you might want to input. So this is how it works. You make a order, and then you hash the order. Maker will sign the order, and then the order is ready to be shared. This is how we hash the maker order. We use EIP 712 specification to encode the order hash. And then we have sign order and signature. Okay. So this is also from 0x. You make order and sign it off chain. And then you only do one transaction in this situation, which is taker injected to the smart contract. Okay. So we have a case for this. It's Joysoul exchange with BNB. So these are maker and taker's address. So also we can put this is an optional parameter that you can put fee recipient to if you want to charge a fee. Okay. So we can see the history on EtherScan. So this is ERC20 token exchange. We can see token transfer, also transfer with BNB. Also, we need to charged by 0x token. Okay, so I like to demo token swap, how to use it. But maybe I can play this video. So this is the token swap feature that I like to demo to everyone. We can first make a deal. Have a simple tutorial for this. And then you choose whatever token you like to trade. Let's put in the trade token. So we use default date for expiration. And then check the summary for this deal. And generate QR code. Oh, need to connect someone. Let me connect to the Wi-Fi.
To understand correctly, you're matching people seller, right?
Actually, there are two different steps that you make your order first, then you can broadcast that over to whatever you want, maybe exchange, or maybe just social media. Because we will generate a QR code for you, you can see that later, so you can just put that on social media so everyone can take the deal.
Really, so people need to exchange and there doesn't have to be any fee, but if you want to.
Yes, if you're the one that feel bad with us, we can actually decide to, if you want to charge something, we can charge it to us. It's not sure. So, yeah.
I'll try if this works this time. Okay. So for now, because I need to sign with my card, so I need to turn on the CoolBitX.
What is it doing? You can tell us what is happening behind the.
Oh, yeah. So now you can see you need to confirm with the card. It has, you can confirm the number and the type of tokens that you want to trade on the card. So need to press like 6 times to make sure everything's correct. So the first page is, it shows the protocol, it's token swap, and then BNB, the amount. Oh, let me do it again.
like them when they're fun.
Inspire for 30 seconds.
Yeah. Okay. So I pressed very fast. Okay. So it generates the QR code. So you can share the code on the Facebook or social media so that taker can scan your QR code and take this order. Okay. I will save it to camera roll and check. Right. So that's the order we just made. Then you can show this code to whoever wants to trade with you. Okay. Oh, loud. Okay. Okay. Okay, so we will offer our mobile phones later that if anyone is interested in to try to use this feature and tell us feedback. Reference. I think that's it. Yeah. Thank you.
Okay, so this was all about all the introductions. Now we go actually to coding. So thank you, Nora. I would love to try it later, but yeah, let's do the code also. So Anton is also from the same team. They have this SDK that I mentioned before that we can do many things with. You will tell us what. But what do we need? Tell us what to prepare to. Do we? How will it work? Do we follow along or?
Yeah, just follow me.
Okay.
Okay. So my name is Anton, and I'm also from CoolBitX, and I'm here to share about the JavaScript SDK we're releasing, which means we haven't officially announced that yet, but we have a ready repo, and everybody can just clone it and play with it right now. Okay, a little introduction about myself. I'm currently a full stack developer at CoolBitX. And yeah, this is my first job, so that's the only title I got. And I've been coding in Solidity since 2016 back then, but it's been 2 to 3 years, but I haven't done really some serious project, deploying to the mainnet or anything production with Solidity. And I always want to try that out. So if you know Solidity, and I know Nina and Alex are going to give a workshop about Solidity, if you have any idea that you think it would be fun to implement in smart contract, just you can share with us, and then I'll be happy to help. So why do we need an SDK? You can see from Nora's presentation that we're a hardware wallet company, that we only have a working product, and we also have our own app. But the problem is we realized that it's hard for us to keep building these features and keep adding these smart contract feature, token swap into our own app, because as a multi-cryptocurrency wallet, it's actually hard for us to design the user interface for different cryptocurrencies, because they all have different user stories. So we figure maybe with this SDK releasing, we can have more developers involved, and they can build their own app with our card, and we can still sell our cards. That's all we wanted. And also, as Nora mentioned before, right now, if you want to integrate with our wallet, there's an option called Wallet Connect that you can just establish a WebSocket communication between your phone and the desktop dApp. But the problem with this solution is you only have two hands, and with our product, you also have a wallet. So that means you have to confirm on the desktop, on your phone, and on your card, just for a single transaction. So that's painful. We don't think that's good user experience. So we want to offer alternatives. Yeah. So yeah, that's why we are trying to build this SDK thing. And what is cool with our SDK is that it's in pure JavaScript. So every JavaScript programmer can implement your own wallet, maybe in a web app, or using React Native to build mobile apps. So this is the basic structure of our SDK that you have to know. Can I have a show of hands if any one of you actually want to try it out right now? Okay. So yeah, so I have a working demo app that you can just download and then run it, and we will give you a card if you want to try it out. Yeah, so you can go to this page first. It's under my GitHub page. My username is Inton Coding, and then you can find that under CWS Web BLE demo. And then just clone it, after you clone it, try npm install and npm start, and it should be working. Yeah, so. Okay, sure. You will also need install. You will also need this npm to start it. Yeah, the link. Okay. So yeah, you can find it here. So after you clone this, you can go to this repo. Okay, so while I'm installing, I can talk about okay, so everybody's ready? No. Is it working? Is it all working? Okay. So you guys are, or you want to try that out? I'm not sure.
Okay, so because we have beginners, we have
Okay.
to also download Git and all this stuff.
Yeah.
So maybe you can show some path so that like some others can follow along, and then we make break, and then others catch up.
Yeah, so you can come and start our GitHub repo. It only has 2 stars right now, and one is me, one is from one of my friends. Yeah, so you can go ahead and start a repo. It's under CoolBitX technology and CoolSJS.
Nora，那你还有卡吗？你不是有一叠？就4张，我这里有1张，那你那2张再看，加一个要吗？点一下看看。
Okay, so to those who have already done, we can try. You want to come over? Sure. Yeah. So right now, you can see this is a React project. Just to clarify, this is my first React project. So if you see something weird that you don't what I'm writing this way, maybe that's just because I'm wrong. So if you go to can you open the code? Nice. So yeah, npm install. Is it working? Yeah. Yeah, I think you can just Google install npm. That should be easy. Yeah. Okay, so if you're ready, we can talk about some more advanced stuff right now. Well, let's get ready. Okay. No, that's fine. You can bring your chair here, if you want. So let me open that up.
Like need to pair
Yeah.
with the Bluetooth first, like.
Oh no, you don't have to put. Can Can you just try click on connect? Does it work?
No, but I'm not sure if it's because of my computer.
I think that's
never
because
use Bluetooth in my computer.
That's because of Firefox.
Then I will.
Do you have Chrome?
I'm Chrome.
Yeah, try that. Is it no? Wait, okay, maybe it's because you have to turn on, how can you show the screen?
Yeah, this is not MacBook.
Can you show the Bluetooth part? Huh. So if you turn this on, I'm not sure why is it unable to pair with. No, it should be CWS and this serial number.
Cool.
Yeah, but I'm sure why your web app cannot open the connection.
I don't know if it's Linux.
That sucks. Try this one.
Let's see. This is cool.
Did you see it?
No.
Can you refresh? No. Let me search it for you. Why is Firefox not working? Fox. Yeah. On Ubuntu, oh yeah. It says you have to enable the Bluetooth. You have to enable this. No?
No.
But it also doesn't support on Chrome. It's also broken. Yeah. Can you see this or?
Okay, I will better find this.
Just search for navigator.bluetooth. You should be fine. On Linux maybe. Yeah. Yeah. This is the same version, Linux version. I mean, just try that. Take a moment. Oh, okay. Okay. Yeah. Oh yeah. You need to relaunch. Yeah. Cool. Come on. Why exactly? Nora， 你还没有别卡，这张卡坏了，这样请 update again。Let me get mine. Did you find it? You should be able to see it here. Only this one? Yeah, try that one. Can you connect that?
Yeah, yes. It's paired.
Yeah, there. Yeah, okay. Let's wait for the others. You just take this one with you. That's it. Nina， 啊，看一下他们好了没？看一下他们好了吗？没关系，没关系，我试试看。Let me see. Okay. 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 So. Okay. Yeah. So then we can have a look about the structure of this SDK. Okay, so there are three things you need to know before using the SDK. Is first thing you have to decide your transport layer. And right now we only support Bluetooth, so you can choose which platform you want to use. Maybe WebBLE module, or you can also use the React Native Bluetooth module if you want to build something with the mobile app. With this demo, we are using WebBLE module, so yeah, you should be installing that already. And the second part is what we call the wallet module here. And this actually is the more complicated part because that handles app registration, all the hardware settings, and how you actually set up private keys in your card. That's what we call the set seed operation. And if you finish all these two steps, then it should be easy for you just to choose, if you're building app on ETH, just install CWS-ETH, and then you should be ready to build whatever you want. Yeah. So these are the structure you have to keep in mind, and then we can go on to the code. Okay. So if you're running, there should be a page like this right now on your screen, and I'm going to refresh it. Okay, so if you look at our React project, you can see on the entrance page here, you can see right now there are 4 main components on this page. The first one is called connections. It's something that's on your screen right now. It's this part. It's called the connection component. And then the setting part, and you can also enable these two. These are wallets and the Ethereum testing. So if you enable them, you have to refresh, and then you will have to connect again. Yeah. So I'm pairing with my cards right now. So the first component is really easy. It's just connect and disconnect. It's defining how you want to communicate with our card. So this part is, okay. Wait a second. Okay. So now I'm paired with the card. Now we can move on to the setting part. This is what I mentioned before, the app registration, and also how you actually set up the wallet inside your card. That means you actually need private keys in your card so you can sign something. Okay, first you can just click on reset and then press your wallet just to make sure that the card is empty right now. So if you just click on register, it will register this current app to the device. We need this process because Bluetooth is kind of insecure. So you cannot just let everyone connect to your card and then sign transactions from your card. That's dangerous. So if you're the first app that want to register with the device, we will just let you register. There's no problem. But in some cases, maybe you want to use multiple apps with this hardware wallet. And at that time, that means if you want to pair the second app with this device, you will need to provide a password. And that password can only be generated from a registered app. That means you need to use a registered app to click on to call generate pairing password or something, and then we'll have a password for the second app to pair. So we can make sure that all the app that trying to communicate with your card is authorized and they have the rights to actually control over your private keys. So you can see now I'm registered because I'm the only app that's doing it. So there's no problem with it. So if I press on get password right now, you can see from the console, you can open the console you want. Yeah, you can see it here. This is the password. Can you see it? Here. Yeah, never mind. This is the password you need to specify if you want to pair another app with this card. So, okay. So until now, you have a pairing device, you have an app, but you have to set up the wallet. And there are two ways you can set up a wallet with our card. The first one is you let the wallet generate keys on its own. And this way is actually more secure, but it's more complicated because it's like when you're setting up a crypto wallet, they will ask you to memorize the numeric phrase. You have to write down the seeds. And with our card, we actually do that in a different manner. We try to convert these seed phrases into numbers, and then we will show the numbers on the card if you click generate seed by card. And after that, we will ask you to sum up all the numbers and then send it back to the card just to confirm that you have backed up all the seed correctly. So if in the future you want to recover your wallet, you can do that. But I'm just going to go with the easy way. That means just copy paste a numeric phrase somewhere and then try to set this as the master key to the hardware wallet. So you can go to this page, BIP39 numeric code online, and then just randomly generate a seed phrase. I'm just going to do this. Yeah. I should be complete in a few seconds. If you didn't set the seed in a wallet, you can try click on this one first, and you will get an error because there's no seed in your wallet, and you're trying to get an address which has to be derived from a public key. So you won't have that available. So the error is something like wallet doesn't exist. It will tell you to create the wallet. And yeah, that's it. So until now, we already have a private key, have private keys in our wallet, and also have the connection and your app ready to communicate with it. Yeah. If any one of you want to try out how to generate the master key from the card, you can change it here. You can just see the process on the card. If I go to wallet, where I set the seed here, set seed, yeah. Change this to create wallet. And then the second parameter, the first parameter will be how many seed phrases you want to generate. So if I change it here, and then I'm going to start over. Connect. Okay, I have to reset that because it already has a wallet in it. Okay, so register again. Now if I click on this button is now create wallet, right? So now this will actually generate the seed by the card. So if you're trying it, you can actually see like the screen is showing 12 seeds and you have to add them up. So as a confirmation that you have backup of the seeds. So this is the more secure way to generate a wallet by our hardware wallet. But yeah, just go with the simplest one. That should be fine. So I have to do that again, reset the wallet and then register again, and then set the seed. Yeah, now it says set seed success, so we can move on. Like right now you have private keys, so now you should be able to derive your address, your ETH address that you can receive like cryptos from others. So I'm just gonna click get address. The first time it deriving the address will be taking a little more time, but just give it a second. And then you can see your address shown here. Yeah, this is connected to Robson testnet, by the way. So you can see I already have some balances here. I can change it to another one. There should be no balances. Yeah, and then now you can show this address to others and then try to receive your ETH. Also, if you want some testnet Robson ETH, you can go to this one. Faucet, yeah. And request for some ETH. This is actually provided by MetaMask, so it's sending the testnet Ethereum to my MetaMask address. So then I have to send the crypto, send the ETH from the MetaMask address to the address I'm trying to use. Yeah, so I should be receiving ETH now. So, okay, then I'm just going to show you a quick demo about how to transfer. This is, you can take a look at our code. It's in the ETH test component, Ethereum test. So you can see from here, the signing part is actually pretty easy. You just have to convert all the parameters into hex string and then just send it with this like ETH.sign transaction and then pass in all the parameters you want to like of your transaction. And then the address index here means which address you want to sign with, because we can derive multiple Ethereum address from our card. You just need to specify which one you're actually trying to sign this transaction. Wow, it's raining. It actually depends on how you, it's theoretically, it can generate as many as you want if you can pass in different like just different parameters for, I want to derive the number, maybe 100 wallets. So yeah, so yeah, this is, if you want to take a look at the code, this is where we're actually signing the transaction. So I can just randomly select an address and amount, select the fees, and then we can leave this data field empty for now. So if you click on sign and transfer, it will try to send this data to the card. So in a second, you will see the transfer amount actually showing on your card, and you can click on the bottom to confirm. Yeah. No, not efficient. Okay. I'll use an address with balance. Nah. Okay, so I should be able to sign it and then broadcast it to the network. Need a second. Confirm. And okay. Yeah, so you can actually see this transaction on the testnet. Yeah, it's here now. Okay, so this is how we transfer ETH. This is the very basic function. And if you want to play something with smart contract, that's actually another form of transaction. You just need to put in some data, like as parameters, if you want to request another smart contract. So I don't have a working Robton smart contract right now, so I'll just leave it. Put some random data here. Yeah. And if you put some data in this field, the card will parse the transaction and recognize it like, oh, this is a smart contract code. So you can see, like, if you have a card right now, you can see actually it will show smart on the screen. That means we don't know what the data in the parameter actually means, so use at your own risk. And this is a smart contract call, so we don't know what's actually happening. No, it's disconnected. Yeah, so this transaction will be parsed as smart contract call. So our wallet is going to show something like smart. That's it. And then I can also just press it and then send it to the network, and then yeah, that works. Yeah, so from this transaction, you can see we actually have something in the input data field. So now you can just put this to work with whatever dApp you want. Just put in different data and put different smart contract address as your destination address. Okay, so yeah, that's all I got from the demo. I actually have 2 more slides here. Okay, so it's working. Okay, cool. As I said before, we really want this developer community to build for our company. So like a bunch of other cool projects can be integrated with our card. So right now, as Nora mentioned before, we're having a 35% discount on all the developers. How do we know you're developers? just give us a star on GitHub, and we will say, okay, you're a developer. And we're also open for feedback because this is still very early version, and we want it to be very easy for everyone to integrate with. So if you have anything, like any thoughts about our interface, how we designed the SDK, we're very welcome for feedbacks. And finally here, we're offering 1 free wallet. No. We're offering 1 free wallet to whoever successfully integrate our wallet to a third-party dApp. So for example, Uniswap, Compound, DAI, this kind of DeFi dApp, you can try to build a small demo website, maybe just fork it from my previous work, and then try to make it work with these cool dApps. And we will offer you a free wallet, and then hopefully when we officially announce our SDK, we will also want to put your work on our blog post. And something happened. Okay, I'm about to finish. Okay, so this is the last slide. You're not a single developer. You're actually coming from some projects, some cool projects, some DApp projects. Please contact us if you see we can have some partnership together. And then we will give you a car for testing. And for example, if you're building a website for dApp, for CryptoKitties or anything like that, you can just tell us, and then we can try to co-brand things together, because I think security matters, and we really want to offer you the highest level of security with our hardware wallet. And we also want to teach our users what is DeFi, what is these CryptoKitty thing, how can you do all these different cool stuff on blockchain, not just sending and receiving money. So if you're building something in blockchain, please come talk to us. And then if you sell any wallet, like if anyone from your website or your web page actually go to our web store and buy a wallet, we will share 20% affiliate with you. Yeah, that's all I got today. So if you're interested in building more with our SDK, I think you can always find us in the WizardAmigo group. Yeah, so thank you.
Thank you. Yeah, we'll do the solidity workshop now. Does somebody want to make do you need a break, or should we just continue? Yeah? Okay, Alex, do you want to bring your computer? I mean, yes, we did.
Like the whole thing, because there's a ton of people who know exactly how shit works.
Yeah. Here is also some cool wallet stickers. So if somebody wants, grab them.
I have exclusive access.
So, okay, let's make like a 10-minute break, because like some people are still interested to check out the cool wallet, and then we do the solidity. Is it okay? Okay, and we can grab coffee or something. So do you want some coffee or something?
Yes. What an amazing resolution.
Can I ask you for the just
Did you see it's such a bad resolution? You can't even read anything, it's very hard. Should we start? I can, but maybe we share it because we have to.
Yeah, but it will be heard.
It's lovely. You want to intro?
Okay, lovely people, should we start with our solidity? Yay! Let's build some smart contracts. Let's go crazy.
All right.
So we have like a little introduction at the beginning. Okay, so maybe we can still mention who we are. So my name is Nina.
I'm Alex.
And this is Fiona. You can come. Let the camera see you too. And that's Fiona. Yay! We're the Play team. So we work with the Ethereum Foundation, where we are working on tooling for developers. And we will use our tool later. It's called Play Editor. But yeah, let's go to Solidity.
Yes, actually, before we start, because some of you probably don't have even any background knowledge in how the blockchain works and how the Ethereum blockchain works and how it does a smart contract and what does it even mean to program a smart contract. So we before we actually jump into the Solidity code, I want to maybe try to explain a little bit of background. So what you need, but we will later anyway show you, is the Play Editor, but in the browser you don't need to install anything. We will use a wallet, which is an extension for the browser, so that we can interact, but you don't need, there are free test nets that you can use to try out things for no costs. And we have a chat support, but and I think today we can manage without the chat.
But if anyone online is trying, this is where you can always reach us also after the workshop.
Yeah.
We try to help, and it's also a community, so others might help you too.
All right, so basic concepts. So first of all, what is a wallet and why do we need it? So in this new web or internet, which uses blockchains and has all these kind of decentralized alternatives to existing services, or at least that's what they're trying to achieve. basically a wallet is what would be otherwise your user account. On Facebook, you create a user account. For your online bank, you go and you have an account with your bank, you log in with your username and password, you can click forgot email, they give you your password back. So wallets basically replace all this. And the way they do this is they basically use math. And there's a lot of math around cryptography, but it's basically, you can use that math and you write a little program that does the math for you, so you don't need a pen and do that all on paper yourself. Instead, for example, you could have a little app that looks like this, and it implements that algorithm, and what it does, it spits out 2 pairs of data. They're represented by those violet boxes, or purple, I don't know. But basically, this translates to zeros and ones, but those zeros and ones are generated through an algorithm in a certain kind of way. And the way that works is that one piece, so if you have any data, like this one here below, I don't know if you can read that because the beamer quality is not so great. It's a text. You can read that. It says, Bob, stop trying to make fetch happen, whatever that means. But the point is that you can use one of those. So on the computer, any data, whether it's video or text or anything, also, of course, translates to zeros and ones that represent that. So now the thing is, because you have that one piece of data that is called a public key generated by that algorithm, you can use an algorithm to combine those zeros and ones that were generated in a particular way with the data that you have, and the result is very, like for humans, it's unreadable, it's gibberish, you don't know what it is, and and now the thing is, this other piece of data that was created with your wallet program or with that math, you can use to turn that unreadable gibberish back into something that you can read, the original content. So 2 pieces of data where you can use one to turn something, anything, any data into something that is completely unreadable, and then you use the other piece of data to apply the algorithm to turn it back. You can use it for two main applications that you can use that for. One is if you have those 2 pieces of data and you publish one, you give it to the whole world, you publish it on the internet, on Facebook, you give it to your friends, then you can use that other part of data that you keep private and you never show to anyone, and you can use it so that anyone can use the public piece to encrypt any data they want, so it turns it into gibberish and they send it to you. And the only person in the world that could turn that gibberish back into something that is readable is you with this private piece of data that you have. Nobody else can. So that means anyone in the world can use your public piece of data, the public key, to turn anything into gibberish and send it to you. So it's a way of sending like a private message. Nobody can read it. Only once you receive that gibberish, you can turn it into clear text. Nobody else can. But it works also the other way around. You can use that piece of data and turn something into gibberish and send it to the world, but everyone in the world can actually turn it into plain data using your publicly known key. But once they do that, they know, oh, this has to be coming from you because we know you were the one that published that. You are the only one who has that corresponding piece of data, probably. So that's a way of signing data. Now, there's a lot of variations in this, but like in core, you can use the public-private key cryptography, have those 2 pieces of data, and you can either use it to have anyone encrypt something and send it to you, and you can be the only one who reads it. But in the other way, you can encrypt something, send it, and of course, everyone can turn it into plain text, but they know it had to come from the one that has the corresponding private piece, which is probably just you. So, and that's basically replacing traditional user accounts, because now you can prove you are you by publishing your public key and saying that's my public thing. And now you can basically send messages and prove that as long as you don't give away that private piece of data, that it can only come from you. All right. So now again, what is Ethereum? So there is a certain software that you can download, or a software that is written according to that specification that Ethereum is about. And here are many computers all around the world. They all run that piece of software. And as soon as they start running it, they connect into the network of everyone else who's running the same software, and that builds the Ethereum network. Now you can run the software with a bunch of friends and make like a private network. It essentially works the same, but you just don't connect to others. So there can be many networks, but they all work in the same way. Now, how does that now fit together with the wallets? So if you have this network running, you can download the software and run it. What it does is those computers that run the software, they synchronize data. So every single computer has an exact copy of the data that all the others have. And that's actually the blockchain. That's the blockchain piece. Now every block contains data, and then every time interval, depending on how long that is, there's a new block that again contains data, and it always grows. And the content of that data, the main content that is actually the thing that we care about, is transactions. And transactions are between user accounts and contract accounts. Now, user accounts means wallets. So these are public-private key pairs, but we also have contract accounts. And the network, but the main work of the network is, of course, I mean, one fundamental piece is that they all the time synchronize the copies of that blockchain and they all have the same exact copy. Now, how does the blockchain work? So there's one thing that I try to explain is now like an easy first intuitive approach about what are user accounts and what are public-private keys. There's another thing, it's hashing. It's also standardized, and what it does, it takes any kind of data on computers that's always represented in zeros and ones, applies an algorithm and creates a very short, actually always fixed length piece of data. And if you run that algorithm twice on the same data, it gives you the same fixed length data. It's like a fingerprint. So because once you have the same input data, even if that's gigabytes of data, you always get the same output. But if you change just a single 0 or 1, like a single bit in that input data, the fingerprint will be different. It's not the same. So you can perfectly fingerprint data, and if somebody later receives the data, the original data, they can apply the same algorithm and see if it generates the same fingerprint, and then they know, oh, that's the correct data for that fingerprint that I have. If it's only one bit different, it will create a different fingerprint. So here are examples. So if you have just a text file with the word fox, you apply it, you get a fixed length fingerprint, which is actually longer than the input. But if you have another text, the red fox runs across the ice, okay, whatever, you create it and get exactly the same, you get a fingerprint, the same length, but a different one because it's a different input. Now, if you have that data and you just change the word runs for walks, that's considered like a tiny change, you completely, again, get a completely different fingerprint, like a different hash. And the same here, if you use the same input text twice, the exact same input, you get the same. So now, how is that important? The Ethereum node uses this, and they use it for the blockchain. So when you have a block that includes transactions between user accounts and contract accounts, they also include the hash, the fingerprint of the previous block. So every block that is added to the blockchain, when the nodes synchronize, if a node has only the latest block, it can see what is the fingerprint of the previous block. So now if any node, because maybe you start the node later, so if anybody now sends you data, you can actually check, if you apply the hashing, do you get the fingerprint, is that the correct block? So those the hashing functions that are used, they're supposed to be cryptographically secure, so it's extremely hard, or essentially it's supposed to be impossible to just figure out by random a big piece or small piece of data that generates the fingerprint. So if you have the fingerprint, there's no way to create data that finds you exactly that fingerprint. You could, if you have a particular fingerprint and you try to find the original, some kind of original data that would hash to exactly that fingerprint, that's what is supposed to be impossible, or take impossibly an impossible long time, like millions of years or whatever. So there's hashing fingerprinting algorithms that are not cryptographically secure, but there are those that are meant to be secure, which means it's practically not feasible to ever generate data the way you want it that would then match that fingerprint. So that's how the blocks are linked together. And the blocks include Here you see these orange colored boxes. That means transactions between user accounts and contracts. But you see also this purple box, which is state. Now, state is not really something that is extra. Basically, transactions between user accounts and contract accounts. Let's take a simple example. Some user account named Bob would transfer tokens, like maybe Ether, to a user account that's named Alice. Now, you can, and then afterwards, Alice transfers some amount back to Bob. And they do that a couple of times, so you have a bunch of transactions. Now, if you calculate together what's the result of all those transactions, you will get a state. But that state can always be derived by replaying all the transactions. So if you don't have the state, you can just execute all the transactions and you will again derive that state. So the state is basically derived from all the transactions of all the blocks that happened in the past. And the blocks are linked together. Now let's just take a look about the transition from one block or one set of transactions to the next in one small example. Now, suppose that's the entire, that represents now the entire blockchain, but it's very simplified. So there's 4 accounts, and those accounts have addresses. So if you have a public-private key pair, like a wallet, the public key that you publish to everyone in the world, the address that your user account, which is basically your public-private key pair, represents on the blockchain is derived from your public key. So this, you could think of this address is essentially somebody's public key. So they are supposed to be the owners of the private key, that other piece of data for public-private cryptography. And they have a wallet to manage that for them. That's the software that helps them to use those private keys to sign data and interact with the network so that they don't have to calculate it on paper and put it in. So this account has 1,024 ETH. That's the amount of Ether that they have. Here's another account. This one is the address. Here's another account. And here's another one. This one is a wallet. And the first one is also a wallet. They just have Ether, like somehow a balance. Those contracts are different. They are not user accounts, they are contract accounts. Contract accounts also can have a balance in ETH, but they don't have a public or private key. So contracts can never start a transaction. They can always react to a transaction, but the transaction had to be initiated by a wallet. Whether that's a computer program, like an app on your phone that acts on your behalf and uses your public-private key to do certain things automatically, or you pressing buttons, that's a different question, but essentially it happens off the chain, and the contract account has code. So basically, when the contract account receives a transaction, that transaction can be, of course, just like transfer X amount of tokens or Ether to another account, but it can also have data. So this is a transaction from this account, which is a wallet, to that account, which is a contract account. It transfers 10 ETH, so that's why the balance after processing this transaction from the previous block and the state goes down by 10 ETH, but the receiving account goes up by 10 ETH. But additionally, there's also data sent with the transaction. And this one is basically, the data is a list of 2 values, the number 2 and the name Charlie. That's arbitrary. You could send whatever you want, but now that is interpreted by the code that is stored in the contract account. Now, it's hard to read, but maybe it's just 2 lines. Basically, what it says here is if, so that's a conditional, if the contract storage, so this contract has a storage, which is a list of values, the value 0, then a big number, then again a 0, then the name Alice, ... There could be more stuff stored in the storage of that contract. So if the contract storage on the position of transaction data 0, so that's the transaction, and the data that is sent with it, there's like a position 0 and a position 1. It has only 2 positions because there's just 2 pieces of data that are sent, the number 2 and the name Charlie. So transaction data 0 is actually the number 2. So this is the transaction, that's the data, and the position 0, that's the value 2. So if I take that number 2 and see contract storage 2, it asks me if the storage in that position 2, does it have a value? So this is position 0 of the contract storage, this is position 1, this is position 2. So 0 counts as like no. This is like a default value, this doesn't count as a value. So we say, oh, and there's an exclamation mark in front. So it says if there is no data, this line essentially translates if there is no data in the storage of that contract in the position 2. And why 2? Because this is the storage position that the transaction wants to ask about. Then execute this line. And this line means contract storage, again, transaction data 0, so the same position, that's the second position, set that to transaction data 1. So we take the second piece of data, Charlie, and we set the contract position 2, which was 0 before, we set that to the transaction data 1, which is Charlie. So you see the 0 is replaced with Charlie. So this is something that happened by sending a transaction to the contract. You transferred tokens or ETH, but you also executed something, the data of the contract, which will always execute in the exact same way, the way the contract was deployed, and you can influence it by providing it certain data. And that's it. There's nothing more. So you have user accounts, they can use their public and private keys to send transactions, which means tokens to other users, but they can also send tokens to contracts, or they can send data to contracts, and the data will be interpreted based on the code. And that will lead to many such state transitions, from this state, applying that transaction to that state, and so on. And that will basically create multiple blocks, each block containing transactions that move the state from the current state to the next by applying transactions. And that builds the blockchain data, and that's synchronized. So this red circle represents all these Ethereum network nodes with the blockchain data. And of course, they talk to synchronize the blockchain data. And the smart contract accounts, they have the code, they have an address, they have all kinds of stuff. On the other hand, you have users, they have wallets. This is the icon of the MetaMask wallet. You can use other wallets. And they manage private and public key pairs. Now they can use normal apps, HTML, CSS, JavaScript, mobile apps, whatever you have. And then they can click buttons, and that creates data that is sent to their wallet. And on their wallet, they get asked, do you want to confirm that transaction? And then by saying OK, the wallet will use your private key to encrypt that transaction, approximately, I mean, something along those lines, which means once the network receives it, they can use your address, which is derived from your public key, but to see, oh, did that data really come from you? Because if we can figure out that's the case, then obviously you had to apply your private key, which can only be in your wallet. So then we will include that transaction. It came from you. What is the data? What do you say in the transaction? Which contracts are involved? Execute it, make a state transition. And that's all that happens. And every node in the network gets a copy. And this is the environment that we will program. So people can build apps. There are wallets. People can generate public-private keys. The Ethereum network exists. People run nodes. There's this giant network. Now the idea is, let's program contract accounts. And those contract accounts have code, so people can send transactions, sign it, and based on that, some results can follow. The blockchain is updated, and anyone in the world can see it. So if this user sends a transaction, that user using a different dApp or the same might see an update because it reads from the blockchain and it sees there was a state transition, some other user triggered certain state updates. All right, so cool. Maybe we can do a demo time. Do you want to do that? The MetaMask thing. Because maybe not every one of you has MetaMask installed, so we could do that. So you have your own wallet, and then we can actually try it out later.
So just to know, like, who has MetaMask already on their computer? So, okay, others could install it. Because if we want to interact with contracts in the browser, this is somehow the best way to do it. So this is like a pop-up that comes as a MetaMask extension. So how do you get it? Open the metamask.io and add it to your browser. Firefox, Brave, Opera, and Chrome are supported. Yes, but I would suggest the browser version for now. So this is now really like a dummy thing for like if somebody wants to follow completely step by step, this is how you add it, confirm everything, add, click, confirm. And once you have it, create a wallet. Agree with or disagree. This is like if you want to give them data to improve, but it's not necessary. Create a password. This is just to log in. And you get like a backup phrase, these 12 words that is basically representing your private key. So you can do this later. Yes, come say something about it.
The MetaMask is a wallet program.
Come.
So when you install it and you click make an account, it generates you with executing the algorithm, the public and the private key pair. And this backup phrase is just representing these public and private key pair in kind of human readable words. It's quite a bunch of them, I think 12 or even 24. 12. So if you write them down even on paper, you can store them somewhere under your pillow in the basement, wherever. You can always, anywhere in the world, on any computer, install a fresh wallet, take those words, type them into the wallet, and it can recreate your public and private key pair, which would be otherwise, because it's zeros and ones, it's kind of hard to read and remember, but with those words you can restore it. So you can make a paper backup.
Yeah, but this can be also done later, because if we will now use it just for testing, it's not so important to protect the account at this moment. So once you have an account, you will be able to see it, and then we can create more accounts. So if you already have MetaMask and have only one account, I suggest you to create maybe some additional accounts, because then we can simulate, once you're Alice, once you're Bob, or whatever. Okay, then you can give it a name, and then basically the end result is you have MetaMask like this. Can you log in? And you are able to see many accounts. And now one more catch. You know that the mainnet is like a place where when you execute a transaction, you have to pay a certain fee, and this is paid in actual Ether. So for testing purposes, we are using test networks, and you have many, Robson, Kovan, Rinkeby, Gurley, but there is another one that is like super fast that we usually use for testing, because it really executes almost simultaneously, and it's called Ethereum. So if you want to add this one, just click on MetaMask under Networks here, and then select Custom RPC. And then we have to put some data in about this custom RPC. There is a link here. I can paste it in the Gitter channel. Can we paste it? Copy, and where is the Gitter? I will just open the... Where do we have it? WizardAmigos. So from here you can actually copy the settings, so then it gets faster, I think. But if you want to type it, can you see it? Is it clear enough? I think unfortunately the projector is a little bit. Yeah, so I think it's best to follow the link. Its network name is Athereum, so Athereum, Athereum, and then URL. Are you trying to type it from here? Okay, then I will just.
Is it readable approximately?
Ava network /2015/ext/evm/rpc. Here chain ID is 43110. Symbol is ATH, and block explorer is athexplorer.ava.network. Big focus. Yeah, it's not focused, the projector, unfortunately, very well, but it's too high to adjust it. Did you all manage? How do you know?
Yes, how it's working?
You should get the network here. Okay, it's a test net, but it's proof of authority. So because they don't have many nodes that have to reach the consensus, it's actually super fast because it just executes immediately.
Yeah. So basically, what you can do is you go to the MetaMask account and you go to the MetaMask account and you click the icon and to copy your Ethereum address. And then you can go to.
It's a part.
Yeah, that's basically how you test if you configured it correctly. Because if this will work, you configured it correctly. ava.network, right? It's just ava.network, the website.
Faucet?
Oh, right. Okay. Let's open it.
So athfaucet.ava.network, you basically copy your address. So here we have to be on the Ethereum network. We copy address. We paste it in the faucet. Faucet is a place where you get free test ethers. And
You can pay for the gas for transactions.
so later when we execute, yes, you have to pay for a little fee for the transactions, but this is test ether, so just to feel how it actually feels later on the mainnet. You request, and then you should be able to see 0.25 test ethers in your wallet.
If you get that, then you configure it correctly.
So you can feel, if you did it already, maybe you can ask for the ethers for all of your accounts so that you give Alice and Bob and their friends some ethers. And if you quickly want to test it, you can go to play.ethereum.org or playproject.io, it's the same, and just click on the editor. So this is the tool that we are building. It actually takes the solidity code, gives you like a preview of the code, and then if you click publish, it should pop up the MetaMask. It asks you to sign the transaction, you confirm it, and basically it should execute super fast. Obviously, we are now all using it, so it's not that fast. Usually it's like in the second. Interesting. Wow. Does it work for others? Did you manage to publish? You have a publish button. Yeah. Which is deploy. So you deploy the contract to the network, but for me, for some reason, it takes very long. Is yours executing faster? Yes, it's executed. It shows you like a contract address and let me see. The point of this testnet is that it's super fast. Let's see. Oh, that's really sad. Today it's very slow. Did anyone manage to publish the contract? And does it say it's published? So I don't know why is it so buggy for me. So did it execute immediately, like very fast? So okay, let me change the network. So now you know that it's working. Oh. Okay, we'll wait for a little bit more, just that everybody is ready to go. Oof. For some reason, our Ethereum, it's very slow. For others, it's fast, but here it's abnormally slow. I don't know. Maybe
if it's fast for others, that's perfect.
Yeah, but it's very hard to show to demo if it's not working properly. It's not even deploying. So otherwise, I can. Can you try to log in, like sign out and sign in again? Or do I switch account? Bob doesn't have any. Okay, everybody ready? Then we can just continue and I'll try to figure it out later.
Can you go back to the slides?
Yep.
This is it.
Yep.
Before. All right, what was before? Yeah. Okay, so now that we have the wallet, so you have a user account. Now the thing is we want to make contract accounts. So what's a contract? You basically write code in order to create those accounts that we mentioned before, where the transaction has data that is interpreted by the code to transition from one state to the next. And that state can be read worldwide by any app. And users can use their wallet to then interact, sending new transactions that are interpreted by the contracts. So how does that work? Basically, the contract accounts, they have multiple properties. They have a contract address, which is generated when they come into existence. They have binary code, which is essentially the code that we write in the high-level language, but it compiles to zeros and ones, and it's like very compressed, so it's not really human readable anymore. But it's small, and you can put it on the blockchain. Oh no. and it's stored with the contract address. Of course, there's a value balance, which is technically nothing else than a stored piece of data, like a contract storage that is associated, but it has a special role that it tells you about the current balance of ether that are stored with that address. It has a storage to store some additional data. It has memory, but memory is something that exists only during the execution of a transaction to transition from one state to the next. And depending on how you wrote the contract, it might need very little memory or more. And that influences how expensive the transaction is. So you, of course, try to use as little memory, as little storage as possible, because every computer in the entire world that runs the Ethereum network needs a copy and needs to update their database. So even if you change like just something tiny, like everyone everywhere has to do that, so it's quite expensive. Then there's a stack. So the stack is something that is when you execute a transaction. The example that I showed earlier is a very simple one, which means there is only one wallet account that sent a transaction to one contract, and that contract executed the transaction, and that was it. But the thing is that the contract account can have code that when a user sends a transaction to the contract account, that contract account, as a reaction, can talk to more contracts. So maybe I send a transaction to an exchange contract, and that exchange contract then talks to other exchange contracts to get the latest informations that they have on people who want to maybe buy or sell tokens, and then gets responses, and that data is maybe used by the contract that I talked to give me a price or I don't know. It really depends. So one transaction that is initially caused by a user can cause a contract to talk to more contracts, and each time the contract talks to another contract, it pauses the execution and asks basically the other contract to do something, and then that contract might start executing its own code, and when it comes to the point where it needs to ask a third contract, it will pause and ask that third contract, and once that third contract executes successfully their code, it comes back to the second contract, which then continues to execute the remaining part of the code, and when that's done, it comes back to the first contract, which now basically got an answer from the other contract, and then it continues to execute the rest. So while it pauses, it adds itself to the stack. And every contract that is basically called to do something also add themselves to the stack. So that's basically part of the Ethereum virtual machine that we program for. And that's the stack to manage those different kinds of calls. And the stack and the memory, they exist during the execution of a transaction. Now the last part is, or two parts that are similar. One is an event log. So a contract can log an event. For example, every time I'm sending some money to a certain contract, in the code itself, it can say, log an event that I received a certain amount of money from that address, and that event is not readable or accessible to any contracts. It's just stored on the blockchain, but wallets or apps with wallets can read from the blockchain and be informed about the event. So maybe another user sitting in front of their app, they will get a notification on their phone because their wallet was listening to the changes on the blockchain and they were subscribing to events from a certain contract address. And because somewhere else, some user sent a transaction that caused something, that event got created by the contract, even though the contracts cannot read existing events from other contracts, but this third user somewhere in the world now got a notification. And in response to that notification, his app can again cause a new transaction to react. And either that prompts the user to confirm the new transaction, or maybe it's configured to do that automatically, to react automatically. So the event log is basically some way of, during the contract execution, to inform off-chain user accounts or wallets, and then they can react. And of course, every contract has a transaction history, which includes any transactions from the day that it was created until today, and of course that will continue in the future, so you can see any transaction that had ever anything to do with that contract. That's the contract accounts. Now the transaction message, the transactions that you send, is basically just like a little letter that you send to the account, and it has the sender address and a signature. So the signature means I'm using my private key to encrypt the thing, so the network knows with my public address and public key that it came from me. So it's like a signing, but now digitally, so nobody can fake or forge my signature. It has a receiver address, the wallet account or the contract account that is supposed to receive the transaction. Now with the receiver, there's one special thing. You can make a transaction, send it to the Ethereum network, and it doesn't have a receiver. It only has a sender. So if the receiver is not a wallet, which means another user, and it's not an existing contract, but it's empty, what that means is the network will interpret that transaction as, oh, somebody wants to create a new contract. So a contract that doesn't exist. So it expects the value, which is the data that you send along. Here in this case, it was 10 ethers and the number 2 and the word Charlie. But now when the receiver address is empty, it expects the value, the payload, that's basically the data that is sent, to be code. Code that will become the code for the new contract that is supposed to be created. So when a wallet or a contract, like I can basically send from my wallet a transaction to a contract, and that contract has a logic built in that it will send an additional transaction with no address, and by that, this contract will create a new contract on my behalf. So I'm indirectly creating the new contract because I'm not directly sending I can send directly a transaction to the network to create a new contract. So that means I have to send the data that in my transaction has to be code, or I can send a message to a contract, and that contract has a logic that will create such a transaction for me to create a new contract. So that causes a new contract to have an address, and the data that was sent with the transaction will be stored as its code. And of course, I can set some initial values for the storage and maybe some initial balance that I send along. So the contract, when it's created, already has a balance. Those are details, and this is what we will program. So every message that we will send to contracts or between contracts will have exactly these pieces of data: sender, signature, receiver, value, which is the amount of ether, and payload. And gas limit and gas price, these are basically params that control so every time I'm sending a transaction, it has to be added to the network, and which costs gas. But every transaction, when it gets executed and runs through code, every command in the code, like in the example before, there was like a condition. If some condition is true, then execute more code. This if statement has, there's a specification how much gas that costs. And for every possible command you can use, you can look up the exact gas cost. So if you have an entire contract written with a lot of code, you can go step by step through each instruction and calculate the gas price. Now the thing is, sometimes you might want to execute code multiple times based on data. Now imagine you're a landlord, you're renting out an apartment, you have like maybe an entire building complex, and you have maybe only one tenant, but maybe you have 100 tenants. So maybe at the end, when you have a transaction, send invoice to my tenants, maybe it sends only a single invoice because you only have one tenant, or maybe it executes that 100 times because you have 100 tenants. So the amount of code that has to be executed depends on the amount of tenants, which is data that is stored in the contract. So in order to know exactly the gas costs, you would need to know all the parameters that influence how often certain code will be executed. Now you could you make a more complicated contract and say, I'm using an oracle, which is something more advanced later on, where you want to execute something based on the current temperature or weather. So you have an oracle service and you ask it for a real world data point. But because you cannot know the data point, it's hard to calculate what will be the exact gas costs before you actually execute a transaction. So some things you can only estimate. You assume that maybe the temperature will only be, I don't know, 20 degrees, or maybe in a range between 0 degrees and 50 degrees. But maybe there's a fire and it's 200 degrees, or maybe there's some kind of abnormal circumstances that you didn't anticipate, and that could, of course, change something in theory. So it's not completely straightforward to calculate gas costs, but basically that's why you set a gas limit, where you say, if for whatever reason, unexpectedly, the gas that is needed to execute hits a certain limit, then please cancel everything. I know I will lose all the gas that I spent. The transaction will not be executed, but at least I had like a stop that I will not burn all my funds that I have, because I didn't assume that this would happen. And you can set a gas price. So for example, if miners include the transaction in the next block, they charge you a gas price. You can set that low. If you set it too low, maybe you set it to 0, then miners will say, why would I include this transaction? They are not paying, so your transaction will not be added. Or you can set it very high, and then maybe somebody will add it faster because you incentivize them. Oh, he's giving me a lot of gas. Maybe let's set it a little bit higher. Usually the wallets pick like good values for you, but I mean, if you really depend on this, and you can tweak those values and optimize it or do something with them. But so essentially those two things are more related to having the transaction executed. But of course, the pure logic needs only a sender, a receiver, a value, and a payload. And those things are just like details. But depending on your perspective on it, they might be very important details, of course. All right, so that's it. So there's a smart contract accounts. They have those kind of values that you can program. And you have transaction where you set those kind of values. And now the whole logic centers around transactions and accounts, which centers around those 8 or 6 things that you need to deal with. Great. So then let's start and try to write some solidity, make an example. And maybe you can do that? Yeah.
Let's see if it works.
Or maybe I can go until the first. Okay. So all right, let's get started.
Do you want to hold it?
Yeah, I like to hold it. All right, what is solidity? Solidity is a language that tries to make syntax and best practices that are optimized for this kind of use case. You want to keep things small and efficient. Traditional languages, because they run maybe on your phone, and your phone is quite powerful, your laptop is even more powerful. It doesn't really matter if it takes 1 megabyte more of memory or storage, or if it runs like for, I don't know, a few milliseconds longer, because you have enough resources, you don't care. But on Ethereum, that all costs gas and it's super expensive, so you want to try to optimize things as much as possible. And Solidity is essentially a compiler. So something, when you write a text file and you type text in it, but that text is written in Solidity, that program will understand it and translate it to something that the Ethereum virtual machine can read and understand. And there are actually many versions of Solidity, because there's not only one compiler. There's all the time new compiler versions that add certain features. And if you compile your code with one compiler, it would have a slightly different output than with a new one. And that can, in theory, even sometimes cause problems. But basically, the real definition, what is Solidity, of course, there's a documentation, but the compiler is always the truth, because that's how your contract will be interpreted. If I'm opening this link just quickly, you can see a whole list of compiler versions. They all have names, and it's a quite long list. And you can use any of those compilers, and there's always new versions with different features. And if you want to write your first line of Solidity, what you start with is usually you add a line that says pragma solidity, and then you specify an exact version or a range of compilers that your code works with. So that's the first thing, and then that makes sure that if a user wants to use any other compiler, it won't even work. And you make sure that ideally you maybe set it to a fixed version of the compiler, and then you know it works only in that version, and maybe you hired like an expensive security auditor who tested your contract for security exactly with these kind of conditions, and it's repeatable. But if you use another compiler version, it will probably work, but maybe you lose those guarantees because the security analysis has not been done for that particular version. But okay. So maybe we can create like a simple coin as a first example, like how can I make my own token? It's not an ERC20 token, it's like a very simplified version. But also an ERC20 token is not that complex. It's quite doable to wrap your head around an ERC20 token and even deploy your own ERC20 token, and it's very similar. All right, so the way you start defining a contract is you just write the word contract. You give it a name, you can call it coin or something more creative. And then you can start adding state variables. Now, a state variable is the way in Solidity how you define those storage slots on the blockchain. Like this code will maybe create a contract account on the blockchain when you deploy it. And of course, the code will be stored with the contract, but it will also have storage. Now, how do you make sure what kind of values can be stored in that storage? In Solidity, this is how you do it. You define a name, you call it X, you can call it whatever you want, and the data that is supposed to be stored now on the blockchain in that slot of storage for that contract is of a type address. Now, in the documentation, you can see it's a 160-bit value, so that means a series of 160 zeros or ones. You can flip them either way. And you cannot do math. So if you try to have addresses and you use like, you multiply them, you divide them, any kind of arithmetic operations, this doesn't work. So, and the purpose of that kind of type of data is that you can store addresses of other, for example, wallet accounts or contract accounts. Because maybe you have a contract that you write and you want to keep track of everyone who has tokens. And of course, they all have an address, so maybe you want to store that. All right, so yeah, an address could be an external wallet or a contract account. So that's the first piece of syntax that you can use in a contract to write your first contract.
Maybe just one thing, because you mentioned Solidity documentation, just to maybe open the documentation page also, because we have examples from Solidity documentation, but there is much more. You can go deeper and it's always up to date. So Solidity readthedocs.io is the place to go to.
Yes, actually you can read it from A to Z, and it starts quite simple, explains some background, and it starts with some examples. And this coin example comes from that documentation, and it's always up to date for each version. So also later when you, you cannot only learn Solidity from the documentation because it's made to also learn it. You then also are familiar with it, and if you ever need to look up something, like maybe you forgot, oh, what kind of value was an address again? 160-bit. Maybe you don't need to know this. But if there is ever like a reason why you need to know this, you can always go to the documentation and look up those things. So getting familiar with the documentation is quite valuable.
Can you check the types in the documentation?
Let's try. Do I still have it open somewhere? Okay, let me try again. Solidity readthedocs.io. Maybe we can even search address type. Let's see what it finds. Oh, I misspelled that. Address? Oh, it even found something. Types. Let me go here. That sounds good. All right. Address. The address type comes in two flavors which are largely identical. Holds a 20 bytes. I mean, many. So 1 byte is 8 bits. So if you type 20 bytes times 8, you get 160 bit. What other types? I mean, there's many types, but we will come to them in the workshop. But this is, you can even search the documentation and then find those things. All right, so if you, so the next thing that you can do is define functions. This is basically something that you would use if you want to talk to a contract, send a transaction. You always include in your transaction what function or what functionality, what service maybe you want to interact with. Like a contract can offer many services, and they are exposed by functions. For example, this address account, even though of course the data is always stored on the blockchain, so a human can download the blockchain and see it, contracts don't have access to this directly. But if you create a set function and say that the set function is public, then another contract or a wallet can talk to that contract's address and say, I want to use the set service. And in the data of the transaction, he sends an address with it, maybe his own address or whatever. And what the service does is it stores that address that was sent to the contract inside of the storage slot that is called account. So it assigns the X, which was sent in the transaction data, and stores it in the account storage slot. So somebody can talk to the contract and update the address. On the other hand, you can define another function, you call it get. You also make it public, and you say it will return data that is of type address. And then you say how it actually works. You say return account. So when a transaction triggers the get function, it will execute this code, which means whoever triggered it will now receive back the value, the address that was stored in the storage slot, because this is the one that we reference here. And that's it. Now, additionally, to making both of those functions public, meaning these are public services that the contract provides to anyone who wants to talk to it, you can write additional keywords like view, and the view keyword just guarantees if anyone ever interacts with that contract can read from the contract, for example, this kind of storage field, but it can never update the contract. So you're guaranteed that this one will never manipulate or change the contract. If you don't do that, the function might update the contract. And whenever you update something, you have to pay gas, because everyone everywhere in the world needs to update their copy of the blockchain with that new data, while reading from the blockchain is essentially free. And the reasoning is, if you run your own blockchain node, it already has a copy of the entire data set. So you essentially just have to ask your local node and you get the response immediately. Nobody else in the network needs to do anything. So that's pretty cheap. But if you want to change something, everybody has to apply that update. That's quite expensive. So, all right. Another keyword that is not mentioned here is called pure. So you have a function that can neither write nor read from the contract. It could be just like a calculation, doing something that just takes the inputs that were sent with the transaction and based on that sends something back, but it has nothing to do with the storage of the contract. You can also set it to payable. That means when somebody sends a transaction, it's also allowed to send some additional ethers along, which are then stored in the contract. If you make a function not payable, you can't do that. So these are just basically some things that help you to have some guarantees around the code that somebody doesn't use it in an unexpected way.
So I was thinking maybe because if we don't do anything interactive, it becomes tiring to just listen. So let's try to open the editor and let's try to adapt the code that we have in the editor to this coin. So just, can you, Alex, open the editor? So currently we have already a set and get function, but we have a simple storage. So now we want to rename it into coin. So can you rename it into coin? So it will also, of course, update. And then we don't have a uint8 stored data, but we have address x or whatever we have there, or account. And then function set takes the parameter account, address account. So not x anymore?
No, it's like this, no?
Yeah, it sets account to the x, yes. And the get function Something is not okay? Ah, yeah, because it doesn't have stored data anymore. So it returns address also.
Oh, yes.
So it should have one variable address that is called account. Function set takes the address x and sets our variable account to the value x. And then the function get, which is a view, returns address. We have to say that it will return address, and then we also inside of the function say return account. So now let's try to publish it and see if it works as expected.
So I go to my MetaMask account. I pick Ethereum because it's fast.
It should be. Let's see.
Yes.
I mean, it usually is, but maybe.
So I will publish now. I click publish. So that sends a transaction that has no receiver address, but it has in the code that I send along, the value that I send along is the code. Oh, you did reject it. Why?
Because it refreshed, so maybe it's not.
All right. So I confirm this one. I hope it will work now.
Otherwise, sign out of MetaMask and sign in again. Yes, I think you have to. There is something with MetaMask.
Is it?
Currently. Yes. Because it works for others.
All right, then let me sign out. How do I sign out? Or can I just disable it? Manage extension.
Yeah, sometimes MetaMask, of course, because it's extension, it also has its own issues. So if you have ever problems like we have now, you can just like disable it and enable it again, and this kind of restarts it. And usually this helps.
Let's see.
Did it work for you again? Smooth? Okay, so it's obviously here.
Oh no, I didn't copy the thing. Oh, wait, stored it. Oh, lucky us. All right, let me try again. So I publish. Now the thing is, it's even like if you publish the contract, I hope it will work now. Why is it not working for us?
Okay, then we use GirlyNet, really. There is other network, so for us it's not working. I don't know why. Use the other network, and because otherwise we just spend too much time. Girly is fast also relatively. It's not as fast as this one, but it still works. So sorry that we will be actually slower than you. Okay, but you see, I mean, you can like easily test the contract, see if it works as expected. You can also, for example, try and add payable into the set function. That means that you will be able to send Ether with, or we do this later maybe.
Yeah, let me just continue. So the thing is, if you deployed it, you will see that this field will actually show you the address of the contract. And if you click the address, it will copy it to your clipboard. Oh, now it worked here too. So we have here the address. So if I click that address, it will copy it. And you can also click on the information button, which will open another website, which is one of many blockchain explorers that give you an overview of a transaction that happened on the Ethereum network.
I don't know if Etherscan actually supports Ethereum network. So if you don't get a link to the Etherscan, then maybe this network is not supported, but Girly network is.
So I can go to the WizardAmigos chat. I just paste now this address that I just deployed. That's my contract because it's now live on the blockchain, which means if you open the editor and you have the same contract source code and you go to connect, you can paste in, you can, let's see. Yeah. So you can paste in the network and then click connect. And now you get a user interface that is connected to the exact same contract. So if I'm now switching in this browser tab, I deployed the contract and I can now interact live with the get method. So if I execute it, it will receive the 0 address because I didn't ever set the address yet. But now let me just go to MetaMask and copy my address, and I will paste the address in to the field, and you see there's like a little green check mark. So if I delete, for example, the last character, it's not a valid address. So let me put that back. So this is a valid address. So if you have a valid an input that is a valid address, you can send a transaction, and that means it will execute the code behind the set function, which means it will set the address X, which is the one that I provided as an input, and store it in the account slot. And if I do that, and I click get again, which will return me the current account, whoa, it's not that.
Not yet, because this network takes longer.
Oh, this network takes a little bit longer. All right. Let's try again. Still not. So maybe on the good, that's why we try to use the Ethereum, because until the transaction is mined, and that can take some time. But you will at some point be able to see the new address. All right, now I see it. So there's this address, that's the exact same that I pasted in. Now if somewhere else another user, like this one, where I connected to the same address, clicks on get, they receive the same address. So essentially, that's already an app. Like I have an app, I can have a form, it's a very primitive, generic one. You can make a more fancy one, but I did not go and host any servers anywhere on Amazon or Google, and now when they use my app, it goes to that servers, and then from there they get an answer. But instead, I just basically from the browser created a new app, and anyone in the world, if I share that address, can already interact with it if they have a wallet.
Which also kind of shows that Ethereum in a way is like a database. It's a shared database that doesn't live in a centralized server, but it lives in the cloud or on the network. So you can from many sites connect to the same address and basically update the same shareable database. So should we go back to the...
Yeah, let's just... So the thing is, there's a couple of shortcuts. So for example, this address slot is not really readable directly by other contracts. That's why we made a public set and a public get function. If you use the keyword public on a storage slot, it's already readable. It basically auto-generates you a function that behaves the same as our get function. So you can already read the variable. Now, another type of data, because we're still trying to create our coin, right, a token. So we say, let's make an address that we store, and we call it minter. Let that be a person that can basically create as many tokens as they want for free. But who is that person or that wallet account, that user account? This is what we will store here. But because we might have many people who will have our token, we need to have somehow like bank accounts, like each address, which might be any address, and a uint. Uint is a new type. We already said what is address. Now uint by default is called an unsigned integer of the length of 256 bits. So you have 256 zeros and ones that you can set in any way, and they are interpreted as numbers. They're unsigned, which means the smallest number is 0, not negative. There is also a type that can have negative numbers, but we assume our balances will only ever be positive numbers. You can have 0 or more tokens. And what you can do is, because we called this mapping balances, you can now write Solidity code where you say balances, minter. Now minter, in this case, is representing an address. So the balances, which is our mapping of the address from minter, will return us an unsigned integer, by default 0, and that represents the amount of tokens we have. Now, if we execute a different kind of Solidity code, we would say balances minter equals 1, 2, 3. We would update the uint, the number, for the address minter to 1, 2, 3. So if we later again try to say what is the balance of the address of minter is an address, it will now return us the number 1, 2, 3. So a mapping is a construct that we can use like a dictionary, kind of. You make your custom dictionary. You say what are the keys? Let's say it's all the Chinese words. And what are the values? It's all the English words. Now our dictionary is what are all the addresses, like a phone book maybe, of contract accounts or user accounts, and we will look up the amount of value that they have. Now every time we make a transaction to transfer tokens to another user account, we basically have to update this phone book, which is not a phone book because it's more like a bank account, like a balance sheet or many balance sheets. So this is something that we also need in our tokens because we want to be able to look up the...
We have accountant. How would you call it in the accounting world if you have a list of accounts and how much is the balance?
Ledger. Yeah.
Ledger.
All right. It's a ledger. Exactly. So let's see. What's the next step? All right. We make that public. So we say it's public. Anybody can see. Like the thing is, we are making now a token and a logic. If you feel that this should not be public, you can create a slightly different code and make it not public. Now the thing is, with these kind of things that are stored on the blockchain, you can still download the blockchain data and see it anyway. The public keyword is only related to whether a contract can directly access that data and retrieve it from the contract or not. If not, somebody can still write a program, download the blockchain data to get the data and then still see it. You can't really avoid, this is not really for any secrecy or privacy that makes it really invisible for people who want to know. It's just for convenience to say, in our coin, we want to basically say there's one minter.
It's almost like an API, basically.
Yeah, you're defining an API. That's how you call that yeah. Right, so because we make it public, we get, again, like a get function. So it's called balances because we name our variable balances. And it's a query function. So our get function now takes an input, and that input is an address, and it will return balances X. So the address that we give it in the transaction, this is the balance that it will return. So the uint that is associated with that address. Now, because we're in the Ethereum world and we are programming contract account on the blockchain, there's some solidity syntax that allows you to get some information about your environment, which is the blockchain, which is the Ethereum network. So you have a magic syntax that you can use, message.sender, and it gives you the address of the contract or user, the account that sent the transaction. So every time our code is executed, it's executed because somebody sent a transaction. What's the address of that sender? You can get that address by using message.sender in your code, and that provides you that value. There is more of those kind of things. You can say message.value, message.data, message.signature. It's basically, if we just quickly, go back a few slides. So I said every transaction has sender, signature, receiver, value, and those kind of things. So those are basically, the message is the transaction that was sent to you, and those are the properties, the sender, the receiver, and so on and so on. I mean, the receiver is yourself. Now the thing is, because a message is not equal a transaction, because a transaction has an initial message that starts the chain, but a contract code can trigger more contracts. And that means you send a transaction to the contract, but that contract executes some code and then sends another message with the same structure to another contract, receives an answer, and at some point the transaction ends, and it consists of one or more messages that are structured in that way. Of course, here's also gas left, gas price, block hash, Coinbase difficulty, block number. What is the current block number? So you have access to some kind of information about the current state of the blockchain in general. Now in this example, we will anyway currently only use the message sender to see what is the address of the sender who sends that transaction. And you can also look them up in the Solidity documentation. All right, so what we create is now a constructor. So this is something special. When you send a transaction to create a new contract, all the code that you put into the constructor, this is how it looks, is only executed once when you create the contract, and then never again. It's not. When you publish. When you click in the editor, and when you click publish, we create a new contract, publishing it to the blockchain, and that code that is in this constructor is only executed once to initialize the contract. For example, if you have a template for I'm always using this example, but you can do that actually on the blockchain. We already paid our landlord in the past in Taiwan once in Ether to pay for our rent for 1 month while we were staying. So if you would have used a template of a contract for a tenancy agreement, when you publish that to the blockchain, you want to publish it and it's signed by tenants. So you actually fill out in the template, also in a normal contract, who is the tenant, who is the landlord, what will you charge, how long will they stay. Those are basically the placeholder values that you fill in, and then that's what you sign, and that's the contract. So the source code is only the template, but when you publish it, you want to fill in those blank spots. So you have a constructor that gets only run once when you publish it to set those initial values. And in this case, we say the message sender, which in that initial publishing transaction is actually the person that publishes the contract to the network, we will store that address in the variable minter. So the person who publishes the contract initially will now be permanently stored as the minter's address, which in our case will be the only address that is supposed to, allowed to create new tokens. So he has basically like a money printer. In that simplified example, it is of course not very practical or useful, but like just to make the point. Now the next thing that we do is we define an event. So again, events are not something that contracts can read, but when anybody sends a transaction to the contract, for example, I want to transfer tokens from myself to somebody else, we want to log an event. So any user in the world who interacts with the contract can get notified that something happened. And what happened is we say the event, this type of event is called a send event. We could maybe say it a transfer event. And it includes data about who sent it, like from, to whom was it sent, and what was the amount. So by many people interacting with the code, you would just get like a long list, a growing list of transactions from whom to whom and what's the amount, All right, now let's define a function. We before saw the get and the set function. This time we define a send function. Now the send function will have an address receiver who is supposed to receive tokens. And then of course, how many tokens are they supposed to get? Now we say the balances, which is our mapping, and we look up the message.sender. So the message.sender is the one that sends the transaction. So obviously we reduce his account balance by the amount. That's the number that we set to be sent to the receiver address. Then we go to the balances and say the receiver's address should be increased by that amount. And when we did that, we log an event that the message sender transferred an amount of tokens to the receiver. So once that transaction goes through, in the future, the state of the blockchain, when people ask for balances, will get the corresponding numbers, and there basically is an update that happened. Also, we create another function, which is the mint function. It also has a receiver and an amount, but when you call that when you send a transaction like this, we just increase the amount of whoever is the receiver by whatever we said would be the amount. So we have a mint function that just basically creates new tokens, and we have a send function that transfers tokens. Now there's all kinds of problems. First of all, what if the sender doesn't have enough funds? Or currently, this looks like anybody can now just create tokens because it doesn't check whether the person that tries to interact with this mint function is actually the minter or whatever the logic is. So we need of course, to add something here. But this is basically two functions. They interact with those, the mapping, and update it in certain ways. And that's what we need for a token. Now, this is some JavaScript code that you can use in an app in order to listen to events. We can copy paste that into our editor, and then we can actually click the send button, and you will see that it logs that kind of event where it says from whom to whom and what was the amount. We can do that in a bit. But let's just finish this final example, the rest of the example. So we have the address minter. We have a mapping that stores all the balances. We have a constructor. So when the contract is published, we store the sender's address to be the minter in that variable, in that storage slot. And we have an event that we define that we can log at any time. We have a send function that we saw before that transfers and emits this event. And we have a mint function that updates the balance. Now, what is new here is we use another solidity element. It's called a require. This is something that is a guard, so we can define a condition. And if that condition is not met, we cancel the transaction and we undo any changes that might have happened already. So if there was one line of code before that require statement that would already change a state, that would be all undone. So that's the thing with transactions. Either they succeed and all the changes are applied, or if there's any problem, it's as if the transaction would never have happened. A transaction cannot go like half through, but then the rest doesn't succeed anymore. Like, for example, we want to transfer funds and we reduce already the sender's account, but then we don't increase the account of the receiver. So that's the guarantee that you get. A transaction will either apply all the changes or none of them. Now, what is the first check that we do here? We check if the amount is smaller or equals to the balance of whoever sends. And if that's not the case, we will cancel the whole transaction and we will give them the message, there are not enough funds, sorry, this won't work. For the minting, we do another check. We basically say, is the sender of that transaction, is that equal, the address of the sender, is it equal to the address that was stored in the minter variable? If that's the case, okay, it goes through. If not, we will cancel the process. So we kind of can check, not anybody with any address can just come to this contract and do something, but it's only in this case, the minter. And then we can also check if the amount is smaller than a certain amount. That's just like a shortcut to express a very large number. And the point is that in programming, and also in this case, we saw earlier uint is a number expressed by 256 bits, zeros and ones. Like, you can really express very large numbers, but of course there is a limit. So if you kind of, for some reason, try to make a change that won't work, that's too big of a number, then that's also not possible. So if you want a larger number, you have to employ like different techniques how to get there. But yes. So that's it, right? That's the entire coin. So you have you define the version, you give your contract template a name, you have a minter, which is an address, you have a balance or a ledger. You have some logic that executes only once when you publish the contract, and it sets the minter to be the address of whoever publishes the contract. You have an event that you want to log, so people can get notifications. And you have two functions. One is transferring tokens and sending out notifications to whoever listens to them. And the other one is minting. And we make sure only the minter address is allowed to increase arbitrarily the amount of somebody. And that's already a token, and when you deploy it, after it's been deployed, it will stay forever on the blockchain. Nobody can ever change the code anymore. It works only exactly as specified. If you make a mistake, that mistake will stay forever. That's the downside. The upside is that everyone who wants to interact with the code can rely that you won't change it after the fact to steal their funds or whatever. And yeah, maybe we can copy actually this entire code snippet. Copy. What about you? Let me refresh. Should I try again? Ethereum maybe works now.
I think your computer needs a restart.
My
Or a browser at least.
But Girly worked. Let's see. Maybe I'm lucky.
Refresh the whole page.
Oh, all right. Okay.
So can you share the contract also in the are you in the Gitter chat? Maybe we can share the code so you can paste it in your. So gitter.im/WizardAmigos Institute/program. Yes. Okay. So let's see. So I get this fun part where the MetaMask doesn't work properly. Yay. So, okay, let's try to publish. So when I publish, let's see again, what is the constructor? Okay, me as a sender will be set as a minter. And then we have send function and mint function. So if I want to send somebody, I have to have some funds, obviously. Do I, as a minter, have some initial funds? Probably not, so I have to mint some coins first. That's what I'm expecting. And then I have two more, basically, balances and minter as view functions. So I can see the value of a minter address, basically, and so obviously Ethereum doesn't work for us. So I'm sorry, I have to switch back to Girly. But at least you see what you can do when you get stuck. Is it working, Ethereum network, for everyone else? No? Yes? Okay, not for everyone, but okay. So I'll try to publish to Girly. Did I set it to Girly? Okay, let's see how, do I have some more accounts? I have Bob and Alice, perfect. And then I will mint. And then I will mint some coins for Alice. No, I am Alice, so for Bob. Okay, so then I will copy Bob's address, switch back to Alice. So I'm Alice again, I know Bob's address. I will paste in the Bob's address and I will mint for him 500 coins. And sign the transaction.
Or you can also maybe switch to Bob's account and try to mint.
So let's just see who is the minter at the moment. Minter is an address ending with 5C1D, which is Alice. So 5C1D, so if I now switch and I'm Bob and I try to mint something for myself. So I go to this contract, I put my address in, and I try to give myself 50,000 coins. And if I try to do this, it won't work. So I cannot execute this transaction because I'm not a minter. So only Alice is a minter, so only she can do this. So let's switch back to Alice. And now we can just check the balances if this was successful before when Alice sent Bob some coins, 500. Yes, and now if you check how much coins does Bob have, it has 500. So now Bob has 500. So let's switch to Bob. So Bob is a good guy, so he will send to his friend account 3. That's his secret name. So Bob will send account 3 some of his coins. So let's send the account 300 coins. We again have to sign the transaction. So now me as Bob can send, but I could mint because I'm not a minter. But I have now 500 coins, so I can.
Because that's more than Bob has.
But let's first do the classic path so that we see if it works out. So basically me as Bob had 500, I now just sent 100 to account 3. So technically I should be left with 400. Let's see if the transaction already went through. Yes, so me, Bob has 400 only, but if we now check the account 3, how much does he have? Oops. So he has 100. So, I mean, it's like a simple example, but you can try out and see and execute these transactions and also see if all the restrictions are set properly the way you want. And all of these, like in the browser, in the tool, where you don't have to now have just a Solidity code and test it somehow, but you can actually kind of like live check it.
Also,
Do you want to?
so if this account address that is there, that this contract was published to, of course it happened now on the girly test network, not on the main Ethereum network. If you give that to anyone else, they can of course connect to the same contract. And if they have received some funds on your contract for this token, they can check their balance and they can interact with the contract and also transfer balances. Now, of course, you would maybe program yourself or hire somebody to build like a nice looking mobile app, and then you would say this is the address of my contract, and that app would then on behalf of the user interact to create and change tokens any way you want. So this is of course just for testing, but it's basically with one click you get to an address that you can give to anyone in the world anywhere, and they can already interact with your same contract, and the same as any app that you program and make the interface, of course, nicer so that it can deal properly with tokens or whatever is the use case.
Does anybody have a question? Maybe we can like answer some question. What is maybe not too clear? So if you try as this address which received the token, if you try to run the function balances, you can put in the address of the receiver and then check how much coins does this user have. So basically, I mean, this is like a back end of the whole story. So now you would have to figure out, if I make this coin, what do I even do? Why did I even do this thing? What do I do with these coins? So maybe we can check some other contracts, like what else is possible to build to get some inspiration. So if you go, Alex, to github.com/play-ethereum/smart contract UI. We have some code examples there. So, no. Okay, are like this, yeah. Okay. No, but I think it's not Play project. It's Ethereum minus Play. And no issues. So here, if you go to source or demo, yeah, sample contracts. So let's check some others. Like we can check, for example, escrow, or maybe you can share this link to the sample contracts also. And let's see the escrow payment. So basically you can create a contract where, you know, if you are one side a seller and on the other side there is a buyer, and now nobody trusts, like the person who is buying doesn't trust to send the money, because what if he doesn't get the item, and the person who's selling can also not bring you the package if he doesn't know that you will pay. So they're in the deadlock. So they have to either use like some kind of Amazon or eBay or some service where somebody charges for this, for being a middleman that we all trust, or you build that kind of a smart contract where you can basically define certain rules, send the money to the contract, and then if a certain condition is met, this money is released. And then the contract acts as a middleman, and because it's just a contract, it doesn't charge a fee for this service. So this is like an example of that kind of contract.
Yeah, it fits into one page. It's quite small. Of course, again, this is just one way to define an escrow contract. You can come up with all kinds of more advanced logic. And just to see, so there's like some helper library that helps you with calculating math stuff, so that you don't make any mistakes or certain things get easier. We define some events. Before we defined an event that would get logged when you transfer, or let me try to make it bigger. Yeah, the resolution of the beamer is not that great. Let's see. So an event when somebody deposits and somebody withdraws, then there is a mapping. This time it's which address deposited how much. So that's very similar to the ledger logic. And then we have a deposits off, and you can put an address, payee, and it will basically return you the amount that a certain address deposited. So for example, if I'm having a wallet with an address and I deposit 100 tokens, 100 ether to a contract, then somebody can basically check the contract, put in my address and see if I really deposited. And then he knows once I deposited, all right, if he deposited to that contract and that is the contract code, then I know for a fact that code only works in that way. So me as depositing it cannot arbitrarily withdraw those deposits again. Now, there is basically a method to the deposit, so I can send some deposit to the contract, and then there's a withdrawal method. All right, I think that there's some part, no, right, and we import certain contracts. And one of the contracts that we import, that's basically like a functionality that we get for free. So that's the code, what do we import? So there's a transfer and transfer primary. So basically, I'm not sure if this is and this is another one. Maybe that's not the best example, but essentially what it does, there's two ways. So you can basically define a third person with an address, similar to how the minter was the only address that was allowed to mint new tokens. You define one or multiple addresses that are considered trusted. Maybe you and whoever deals with you need to agree on those addresses, and those are the arbiters, or some basically people or that are allowed to resolve the conflict or release the funds if in a certain time nobody files a complaint. That's one way of dealing it. So you can, instead of just relying on Google or Amazon, you can maybe do it with friends or with whomever you trust. Another thing is, because we're dealing with smart contracts, there are so-called Oracle services, and they work in a way that a certain person, company, or multiple companies can deploy a smart contract and then listen to events that get logged by that smart contract, the same way as you might receive notifications, because we define events that get logged. Now, the thing is, how an Oracle works is, in my escrow contract, can define a logic that when I call the deposit method to deposit some funds to my contract is supposed to talk to that Oracle service and tell them about it. the organization that runs, or the organizations that run this contract, get an event that that contract logs, and that informs them that somebody uses an escrow contract and they have a certain deposit and they want to do certain things, and they defined that we should ask, for example, certain data sources like the.
Yeah, I have an example. I mean, we built like one simple app, but currently we didn't update it to the new solidity, so it's a little bit broken. But the point was basically we are a group of people. We want to all commit to be more sporty. So we say, okay, let's bet that we will do every day 10,000 steps. Who's in? Let's do it all together. Let's make a smart contract. Everybody put some money in so that you kind of commit to this mission, like to the goal. And you say, okay, I'm investing my money in so that I make sure that I will do it and everybody else does. And if we all stick to the goal, we get the money back. But if somebody doesn't, we others share his money. So basically, let's see, if we all do it perfect, then we just accomplish the goal. But if we didn't, then perfectly, we also can earn from those who were lazy and didn't do it. So we can use a contract to make that kind of contest, which is kind of ridiculous if it's 5 people, because then you can just put it in the box. But what if the whole Chang decides to make that kind of competition? Who will collect this money? What if this person just disappears with all the money? Or will this have to be like some kind of a institution or some sponsor that everybody trusts, like Nike or somebody who decides to be a sponsor for this? Why wouldn't we make it ourselves? So you can basically use that kind of contracts to create, like, I don't know, some kind of games or contests or something like that. And then Oracle, how it comes into the play, how will we know that somebody actually did 10,000 steps? So we connected it to, we made it based on Fitbit app, watch. So it measures your steps, and every day it checks if you did these steps or not. And if yes, it basically kind of marks as done. Inside of the contract, it sends the transaction. But contract cannot go and check on Fitbit API if you actually did this. And that's why we need these external services called oracles who can do this. And they basically are notified by the contract through the event that they should go and check. They check and send the notification back to the contract, and contract logs this information and says like, okay, this person did 10,000 steps. And it can actually track all this totally automated, and at the end, even split the money back to the accounts without anyone touching a button or anything.
So yeah, basically if Fitbit as a company would operate an Ethereum smart contract, and of course our smart contract, which is either an escrow or the game, could ask the smart contract from Fitbit to give the data, and we would trust that smart contract. But if Fitbit doesn't do that, or the company that operates it, we can ask a generic Oracle service, and you can even very easily set up your own Oracle. There's software projects that allow you to basically run them on a server. And what it does is it deploys an Oracle contract, and then any contract who wants to use an Oracle service would talk to your Oracle contract, and you, in parallel to that Oracle contract on one traditional server, run a software that listens to events, and those events include the address or the traditional web data source that you want to ask for certain information. So the Fitbit, the company that operates Fitbit provides a traditional API. So our contract could send to the Oracle contract the data about which user account, in the traditional sense of a user account, wants to participate. And the Oracle contract would receive that data and then ask, their server listens to that contract and the event and see, oh, somebody wants to know, wants this information. So they make a request to Fitbit on your behalf to the API, gets the data, and whatever is the result, they send it back with a transaction using their wallet that is operated by that server to their Oracle contract, and then sending it back to the contract who initially asked. And we in our contract can then program to execute certain logic based on that result. Now, how to exactly set up those oracles? There are Oracleize is one project that builds such a service. There's another one that is called, what is it? Is it Chainlink? Yeah, Chainlink. So the idea is that there's not one organization that runs an Oracle server, but there's an entire network, and you can ask random oracles for the same information, and they independently make those requests. And if the data comes back to you, you can compare if all these oracles answered in the same way, so then it's maybe more trustworthy. The oracles could also be to ask just a sensor. Like imagine there's a supply chain from somebody creates ice cream, delivers it somewhere, and then when it arrives, it's melted. Like maybe you can install a sensor that is connected in the Internet of Things to something, and you ask that sensor, was the temperature during the whole ride on the right temperature? What happened to the ice cream along the lines? And those sensors could be the data source that you ask. And if enough of those sensors give you a certain answer, you trust it, and then you execute certain logic. But yeah, you have to think about how to structure that oracle. But now you have many more capabilities of how to do and design that. And once you deploy the contract, people can read the contract and code and decide whether they agree with this or not. And it's not like a black box that you have to trust in, so that you would usually traditionally be just very big and large companies.
Another example that we also built like for one workshop was voting. Basically, imagine you have a fund. We all together, I don't know, say that we will support young artists or whatever. And then we basically make everyone can apply for the funds. It's visible, it's transparent. And then we also vote, and also this voting is transparent. And then basically based on who gets the most votes, the money is allocated to this person automatically. So you can make that kind of solutions. So whenever there is like some kind of a trust issue or transparency issue, you can build a solution where people can kind of trust the contract instead of institution or a brand. Do you have any idea, like, or like, have you ever thought about what kind of a smart contract could you build, or would you want to build? Or is this completely new and is like, oh, I have to now wrap my head around all of these possibilities? Do you want to go deeper in the code, or would you like to talk more about like some kind of examples, or should we make it like open discussion? Yeah, I mean, based on my observation is that the space is like super new. So the language is out, the possibilities are out, but there is not enough contract examples where you can actually just take and reuse there is like ERC20 standard, and there is some couple of that kind of standards, maybe for tokens. But I absolutely agree, and I feel that this is like something that needs to be done in the future, and we are lobbying for this, that there should be contracts as a service, so that when somebody comes and wants to build something, can already take an existing contract, basically slightly modify it and reuse it, and it works. But currently, what is the space like? Like maybe we can just share what we started to build like 2 months ago. It's called Smart Contract Codes. It's a search engine for smart contracts. It's this. So basically you can find all the contracts that were ever deployed. Currently, we have only 1,000 contracts in, because we are using peer-to-peer database system, and we have to kind of like brush it up a little bit. But the idea is that at least until we have these standards, you can at least go and browse other existing contracts. And we will also ask auditors to give us a list of the contracts that they actually audited from this contract, so that we can put some badges on, so that users can go see all the contracts, see contract examples, see which ones were actually audited, which means that they don't have or like it's very, very tiny chance to have a security flaw, and basically work from there on. It's smartcontract.codes. Codes, C-O-D-E-S, codes. Smartcontract.codes. It's alpha, so this is something that we are working on. We are part of the Ethereum Foundation, but we have a budget for 2 people only. So we did this editor and we started this project, but we are lobbying now for more funding, because then we can build it faster. Otherwise, it will just take some more months. But I agree, I think that this is like a burning issue.
Yeah. So one thing is, we of course plan to add certain categories of like popular contracts or audited contracts. So once you search through all of them, you can maybe find the ones that are kind of highly in demand. Another thing is there's a lot of security-related organizations in the space. One of them is called Open Zeppelin, and this one is an ERC20 template that is audited, and you could use it. And this is basically the same that we had before, like a token, but now it's compliant with the ERC20 rules, and that's the contract template. And this is, for example, a very much in use template. Like ERC20 tokens are a thing. You probably heard of them already, and you can trade those tokens and use them, and they're compatible with the standard interface that an ERC20 token supports. And I think those organizations like Open Zeppelin, they are exactly working on this to audit contracts and also to come up with useful templates. Like ERC20 is one of them, but if the Open Zeppelin also has a website or a project where you can look up templates. Also, maybe I think you mentioned in the beginning the ERC 721. So for all kinds of standards and use cases, they provide the best practices and provide those, so that people who actually want to build solutions can reuse those audited contracts to put together basically new contracts or standard ones using those best practices, or directly just taking a template and publishing it for their use case. And then that comes with the guarantees that they audited it and spend a lot of effort. Experts spend a lot of effort to make sure that this is secure. I'm seeing in the space a lot of people who come maybe traditionally from finance, and the first thing that they do, and even banks experiment with this, to redo all the existing use cases that they are already familiar with and just now do them on top of blockchains, and see how that works. And it has some problems with performance sometimes, but it might bring some other benefits to solve certain trust issues or whatever they have, or maybe certain transparency issues if they want to do that. And that's one thing. And those are maybe useful for those organizations that deal with those use cases, but for a person that otherwise never was involved and maybe used an online banking app, or let's say a trading app, that's kind of like, yeah, but what does it have to do with me? But on the other hand, all of a sudden, if I meet like in Chiang Mai with like 5, 10 random people that I've never seen, and we want to organize an event. Now, if it's free and we get all the sponsorships, it's fine. But if that would cost resources, because we would actually hire people and make like a really nice event, then how do we all chip in the money? And if those, maybe we have an entrance fee, how do we collect the money? And how do we make sure that this will all work out in the end? Because I actually now organize the event with random people that I've never met. So do we now, for that event, go to a bank, open a bank account together to collect the money? I mean, it's kind of complicated, and maybe we just don't do it, or we hire a company that does that. But now all of a sudden we can actually, like if the people that we invite in the event that we do is around people that are familiar with already wallets and use crypto, then all of a sudden we get the opportunity to leverage that. So we can build maybe an app or reuse existing apps to chip in money together or distribute money in certain ways. And even though I never met those people, I have certain guarantees, and all of a sudden I can do this relatively low budget. So I'm thinking a lot of new use cases are possible, and people need to explore that basically were impossible before because it's just too much effort or it's just not possible. And you would only do this if you already have a company or if you already have people around you that you trust because you know them for a long time. So that's kind of like, while the banks or the existing people that deal with those financial use cases come and build their solutions again, top down, and maybe discover new ways. Also bottom up, some people will just start using this and create certain things or solutions that weren't possible before. But yeah, it's a new space to experiment, and we'll see where it will go.
Yeah, so I mean, we come from the startup background. Before I became a developer, I was running a startup. So I'm thinking as a small business. So for me, these kind of ideas, what to build with smart contract is how to organize as a company or some kind of organization or maybe a grassroots or NGO or something. But of course, if you have a finance background, then maybe you are thinking about how to make, I don't know, insurance systems or stable coin or something. But this is like something that I am not so familiar with. So of course, I don't come with that kind of examples. But yeah, I think that for every field, there is a chance. But there should be templates, I think, yes. Maybe this is, again, a business opportunity in a way, because to create a very, very high quality contract, you have to like put a lot of business logic in. Then to write it, it's maybe not such a big problem, but like to think about it and to structure it, it's a lot of work. And then to audit it, like auditors are charging like from $30,000 on for one contract. So to have like a high quality audited contract, this is like maybe 100,000 euros or dollars. So in this sense, if somebody decides to create something like that, maybe they can even sell it, because then somebody can make something out of it, like build a new business or organization and save this money that was invested for buying that kind of contract. Maybe.
For example, when it comes to an exchange, usually to open an exchange, that's not what a normal person does. But like, for example, there's now a decentralized exchange. So if you make a contract where you basically, it's not maybe an escrow, but like you write all the logic that is necessary for an exchange. And once you deploy the code, nobody has to trust you to be the person who receives all the funds and then pay out everyone accordingly. But you just basically publish the source code and people can see, okay, this thing will act exactly in that way, so I can trust it because it's on the blockchain. So you can create your own exchange. And that one here is one that uses the prices from 11 different other exchanges. So all these contracts that theoretically can exchange, they can have some users, but you can of course find those and then basically build contracts that talk to those contracts and make your own exchange. And they also have a GitHub account, so that here you can find their source code. And in general, if you search for solidity template source codes for an exchange or decentralized exchange, you might find examples.
Can we check on smart contract codes if we have any exchange?
let's see if,
I mean, we have now just thousands, so it's.
I mean, that's now a very particular, like, we had voting, we have tokens, I mean, it really, the use case can be like arbitrary. We had a sport competition.
What about this, Laura, what you were showing before, a swap? What was it, 0x swap? It's also a smart contract?
Yes.
So, and did you build this smart contract in your company, or you use the template?
Use it.
So you use the standard. Okay. So we have to.
0x.
You can search for 0x.
Let's see 0x. Maybe we're lucky.
No, but every contract has this.
Interesting. Let's see.
Yeah, every contract.
Yeah, right.
No, but wait, how many pages?
56. Okay, so not every contract, but yeah.
But maybe if they have any kind of address in the contract, they have 0x.
So of course, so what are useful queries? That's why we will add soon some filters to explore a little bit how you can exactly search. You can search for whatever, but you have to be smart about it. Like it's Safe Math is a popular library that gives you some certain conveniences around calculating so that you don't make mistakes with rounding numbers when you want to calculate the price. That's kind of important. And OpenZeppelin audited and maintains that library. It's a Solidity library. If you put the name and search for it, you might find contracts that use that library. So if you are trying to write smart contracts and you want to use audited templates from, for example, OpenZeppelin or actually any template that you found, you can search for the name and then you find contracts that use it, so you can see how is it used by other people to build their contracts. And that might give you inspiration, and then you just open it and see how they do it. Yeah, otherwise, I think, I mean, next to those examples, whether you search them on the search engine or you find like a list of best practices somewhere, the Solidity documentation is basically what guides you step by step through all the features the language has.
Yeah,
and
but this is still like features, but like what do I do with it? I mean, I can understand that people want to, you know, like one thing is like when I know what I want, then I will go and build it. But first, like where do I get inspiration also? So yeah, these are all parts of this technically.
Yeah. We have another example. I mean, I might not go through because now it's already very long, but this one would be a ballot. So you define an address of a chairperson, you define a voter, and the voter can have 3 properties, like a weight. Maybe every voter's vote is counted the same, or maybe not. What they voted, if they voted already, and what they voted for. Then you have a proposal. A proposal could have a name and a count of votes. Then you define the mapping where you say voters, and you can map addresses, which means if some voter with their wallet, of course, has an address, what is the data about that voter? And we already saw a voter can have a weight, whether they voted or not, and a vote. And then you have a list of proposals. Each proposal has a name and a vote count. And then it's again making a constructor. So in the beginning, you run that once, you define all the possible proposal names. And when you do this, you say the one who publishes this will be the chairperson. The chairperson has the voting weight of 1. And then for each proposal name, you add the proposal to the list of possible proposals. And then you just start defining your functions. So you can define a function, give a right to vote to some address. And then you check, okay, only maybe the chairperson can do that. And you make a bunch of checks that you want. You define the weight of the voter, and that's basically defining a new voter. So then they can vote. So if you vote, you basically check if the voters, so the sender that sends a transaction, is he actually a voter? And did he already vote? Does he have a weight that is greater than 0? Because if his weight is 0, then his vote doesn't matter. And then you see what proposal are they voting for, and you increase the vote count of that proposal. And then in the end, okay, give right to vote, vote. And then you have a function that says winning proposal. And it goes through all the proposals, checks the weight count, and sees which of all these ones has the highest vote count, and it returns that. And I mean, that's basically it. And then, of course, you could also say winner name, which reuses the function for winning proposal to get that proposal, but then you return the name of that proposal. So it returns the winner name. And the winner name is actually from all the proposals, the address of the winning proposal, and from that proposal, the name. And then you have a basic voting contract. You can, of course, program different logic and conditions and what is allowed and who can vote. And are there, maybe you want to even define representatives. And then every voter has to elect a representative, and those can only vote, and you can define the checks for that. It really depends what you want to do.
Sometimes people say like, but yeah, why do I need Ethereum for this? I could just like have that kind of an app running somewhere on the server, and it could also do all of this. The problem is just if this would be like something that actually matters, that is like national elections or something, and it's hosted on some web page, and the control over this has a current prime minister who can then go and like a little bit, I mean, his team adapt the results, then maybe this is not something that we want to trust. Maybe
which might not happen now in a first world country, but I heard like there are countries where people meddle with this. But it's not only about this. Even if you have your little, let's say like just a group of people, and you want to just vote on some money or chip in money together, and you structure this, like how would you ever do this if like there's one person who's like knows a little bit of programming and is an IT guy, he can host this, but everyone then has to trust that person. But if everybody has a wallet and you use smart contracts, then even if you don't know, once you learned the basics, you can do it, and you don't have to rely on some friend that you have, because in practice, whenever the amounts that we're talking about or the impact that would come from this exceed like a certain value, you might just not do it, or maybe you will only participate in things that are organized by maybe your company or like your insurance or whatever they do if they run a competition, but you would never organize that yourself.
Yeah, but if you organize that kind of competition and then we want that all this money is collected and split, we have different bank accounts. Do all these bank accounts even have an API that I can use in a traditional app structure? So like many things are not even possible to do with traditional app building.
Yeah, somebody would need otherwise to open the bank account, all the money goes there, and that person sits down and transfers the money one by one, like a trusted accountant person or something. So that's like, how do you get together so much trust to do all these use cases all the time? Most people rather don't do it then at all, because it's just too much effort, too complicated, so many things can go wrong. But now this theoretically becomes almost easy. If you reuse templates and the people that you want to do this with are familiar with how the things work, then it goes into the realm of possible things that you can do.
Any other thought or question, or we wrap it up and go grab lunch together?
Yeah.
Voting, if it's used by any, you mean the voting contract if it's used in practice?
I mean, I heard
yes,
there
is Moloch, like
no, by a country.
By a country. I mean, okay, if you heard something, I have another.
So for a country, I am not familiar with any country that would consider this, but I mean, there's a certain countries that consider whether they should really give out like a digital currency on the blockchain where they maybe still have control, but there's always like some news where countries and central bankers discuss this kind of thing. There are some kind of like, maybe you could almost call them like funny countries, like that, like some micronations that are very small that experiment with those kind of things, but they're like, can you really even take that seriously? I mean, maybe they even issue passports, and some of those micronations even have passports that get accepted in certain rare conditions, but not by any major countries. So it's more experimental and maybe more newsworthy. But for sure, in countries where they have problems, maybe with inflation, people already, of course, use cryptocurrencies to avoid maybe that their local currency inflates. So in this sense, they already use tokens or cryptocurrencies, and that's kind of, and if one of the cryptocurrencies they use, it might be Ether, then if they use already a smart contract for exchanging that, they already use the smart contract, and now if the smart contract has like slightly more features, it can quickly come to the point where you can maybe have some decisions how that exchange works, and maybe some voting is evolved, and maybe people come up with more innovative apps. So yeah, countries use that, and in that sense, or people in that country use that, and central bankers think about it, and micronations experiment with it, but of course it's not yet any major country that would seriously consider doing voting on blockchain.
Yes, but
anytime soon.
like there is one example in the Ethereum ecosystem. It's called Molog DAO. DAO, DAO, is decentralized autonomous organization, and they kind of like a cooperative in a way, but autonomous. So you can write in some rules in the form of contract, and then these rules are law inside of this organization. So
kind of like an investment fund.
Yeah, and this one is used, this Molog DAO, as an investment fund, so people can kind of pull in money together, and then you can apply a project for a grant, and there are rules how this works. So members, they set certain rules, how they vote, based on who gave how much money, and I don't know, if you want to go out, how much money can you take, and la la la. And then basically they vote together and they support projects. So this is like an example of voting that is not, of course, on a national level, but it's something that people are trying to experiment with. And because it was mentioned before, like, you don't know how secure these contracts are, nobody now dares to actually go and make it on a national level and move everything there, because what if it doesn't work out? And then, so maybe to use it in parallel with still traditional system and trying out until you see that it's actually working, and then moving it. But it's like Ethereum started, I think, in 2014, like the first lines of code were written, and it's kind of pretty fresh to go like national or even international.
Fragile. You need to have a digital identity, and it hasn't been solved yet. Like, you cannot prove that this is this person, and you cannot like control who is participating in the system, who is like trying to fake. And so because you cannot have digital identity on blockchain right now, and it hasn't been solved, basically you cannot do voting except for maybe DAOs. And I think with DAOs, like, in my personal opinion, the use case for DAOs is to distribute some kind of funds, and usually I think DAOs are good for donating money. Basically, we have a pile of money, and now we vote how do we donate those funds, because we're not afraid to lose those funds. It's okay if the voting is incorrect, because we are donating, therefore it is okay for us to lose. We just want to find like a good enough way to allocate those funds. But when it comes to like actually getting a return on those funds, I think there's way more problems that are there. So I think basically until identity on blockchain gets solved, you cannot use voting for like big problems. You can only use it for simple things where if you fail, it's okay to fail.
Any more questions or comments or thoughts? Like, I think the logic of the Molog DAO approximately works like you can get an invite to join and put some funds in, and then from all the project proposals that might exist, you can vote with the money to spend it on, and then everybody votes. And if there's, I think, I'm not sure if they give you like some way to adjust what's the threshold, but like if the majority gets votes for it to some degree, then the funds will be allocated to that project. But there is a certain period of time in they call it a rage quit. So somebody who put in money but doesn't agree with that decision, in that period of time, they can just quit the Moloch DAO and take their funds out. And then it will the money will be spent for that project, but you because you're part and your funds are in, and you can also vote. If you really don't agree with a certain vote, you can then rage quit and take your money back, and then you're again out. So I think that's very roughly the logic. And now maybe there are better ways to organize like a fund and manage the funds and allocate them to projects. But yeah, that's one of them. And of course, people try to iterate and come up with even better models. Yeah, right. There's all kinds of frameworks that will help you to build your smart contracts around co-governing certain things. There's even something it's called a token bonding curve, where when you have a market with when you have a token or when you have funds and you want to trade that on the market, you always need some buyers and sellers or some kind of mechanism, or exchanges need to make sure that like somehow it's possible to sell and buy, and how do they do it? And usually there will be ways, but if you personally create your own token and your contract and nobody even knows about it, like how will you now make sure that actually somebody wants the token? And if there's like 100 tokens, and then maybe your friend buys one token from you for $5, then theoretically, there's 100 tokens, one was sold for $5, so maybe the price is 5. But what if there's no additional sellers? You maybe cannot find all the rest of you cannot sell all the rest of the tokens. So the idea with the token bonding curve now, will this be successful or not, I don't know, is that you define like a function or like a curve where you can basically say what is the price based on the amount of tokens that exist. So basically it's predefined what will be the price of the token. So let's say the price is 0 when there is 0 tokens. So you grabbed your first token because it goes in steps. But as soon as you bought one token, when you want to buy the next token, let's say the price is 0, you want to buy 5 tokens. But after you get the first token, the curve defines once there is 1 token, the price is now not 0, but is 1 cent. So the second token costs you 1 cent. But once there's 2 tokens, the price is 3 cents. And so basically, if you buy a certain amount of tokens, the price might change, but it's predefined. There's not other buyers or sellers. Basically, you buy the tokens from the contract, but it mints it for you. And you, in return, maybe you buy them with Bitcoin or Ether or whatever you have, you put those tokens, the contract will now have the tokens. Now, if you sell the tokens again, you send them back to the contract, and it will take the Bitcoin or Ether it has and pay you out. And for each token that you sell it will technically destroy the tokens. But it pays you out from the funds that it currently stores, whether they are Ethers or Bitcoins or whatever. So you could make a token curve that says in the beginning, maybe it's a project, and you say in the beginning you buy the first tokens and they're cheap per token. But then once you start buying more and more, so who joins early basically can buy a lot of tokens for relatively cheap. But then once a lot of tokens are already in circulation, then the price is very high. And then the contract will use a certain percentage of those funds to try to make the project happen. But the rest will be stored in the contract to pay out anyone who wants to sell their tokens. And now if the project actually is a project that makes sense, maybe they will offer a service where you can use the token that you bought in to spend it for that service. So the token can also has a utility. So people will have this token all the time because they know they can use that service that is provided by that organization or project. And maybe if that's a valuable project, that's cool, people want to have that token. And initially to give that project funds, people can invest by buying those tokens, and the early investors might be getting it for cheap. But once you sell the token, you get back what you put in, or maybe there's even a logic that say when there's like a certain cut, you only get for each token that you sell, you get only 90%. From what would other so the price for which you buy and sell could be different, and the difference could be spent on the project. The thing is just one example that I heard, like Steve Bezos, he's like Amazon is very valuable, but if he would sell all the stock that he has, he wouldn't actually get the price that the stock is listed at, because maybe that would crash the price or somehow there would be fluctuations. So this is not so transparent, but with the token bonding curve, you literally, based on how many tokens you have and how that curve is designed, you can see how you mint or sell the tokens and what are the rules around it. So it adds transparency, and you can basically play with those models, and you also always have buyers and sellers, because you sell them to the contract or you get them from the contract. So even if you create your own contract in that way, these are like some new instruments that people can experiment with and play with, which would, without blockchain and smart contracts, this just doesn't exist in the world otherwise, in that sense. So that's token bonding curves is one kind of smart contract that tries to do these kind of mechanisms.
Thank you. I was just thinking about smart contracts. I like gambling, and my friends do as well. So usually we just put money in a pot, and someone is the cashier and do the betting, or we send money to each other, and if we win, we split it up between us. It doesn't matter that much. But if you're a larger group, that would be really nice with a smart contract. I know my friends who had like friends they didn't know so well, and one time a cashier just fucked everybody over. So a smart contract with like gambling groups could maybe be a nice solution somehow. Yeah.
And oracles are basically kind of like no. Oh. Well, I think oracles are also basically gambling. You're gambling, and as a result of your gambling, the oracle will give a more accurate result because you're willing to gamble and bet on something being true in the future. So I think, yeah, that's just another way of gambling.
Do you mean like? Did you want to say that like every oracle is a gamble, or do you think that they all?
There are winners and so there are winners and losers, and so basically it's like sports betting, right? So there's one group of people on one side, the other group on the other side, and there's some kind of a question, and there are maybe two or more answers, and so each of those two groups of people, or maybe three groups of people, has to bet on something. So it is maybe a more complicated way of gambling, but as a result of that gambling, it is possible to get a better prediction about the future if those, like, some participants are very educated.
No, I just remembered last time we had actually Claros. Claros is also like a company. It's actually a cooperative, but it's a court built on top of blockchain. So basically, they have a list of people who can be a jury, and whenever there is a dispute, they send this dispute to how many people do you want to vote or give opinion on the dispute. And then, I don't know, if you think it's really important, you maybe want to engage like 20 random people, and you can even select like certain parameters, like do you want them to be from particular field or something, and then you can actually send the request out anonymously, people vote, give the results, and this is also like, I mean, gambling in this way. I mean, gambling, what is gambling even?
Yeah, So in my opinion, that's kind of like one of the killer features or of blockchain is dispute resolution. Every contract, every smart contract, I think, is a potential dispute to be resolved. And so eventually, if you have side chains and plasma and all kinds of chains inside of chains, eventually, if there is some kind of disagreement, the final resolution is forking the mainnet, which is kind of like basically blockchains where it shines is when people need to solve disputes, and a result of solving disputes is called consensus. And blockchains are a system for one way of reaching consensus.
Yep. Anyone else? Some thoughts, or maybe do you want to share your trading project that you're working on? Just like maybe to use the opportunity to just tell some. I mean, he's actually active in trading, so maybe it's interesting at least to one person. I mean, a couple of words. What is it about?
Oh, okay. I'm working for a small Italian company, and we built our trading platform built from scratch, and the project is born for trading securities in the traditional, in the traditional field, but in the last 3 years, I think, we start to trade also with cryptocurrencies, and I don't know how.
What does it do?
Is
because I'm totally not familiar with trading.
Yes, there are many. Is a software built from many parts, but we have a part of software that runs on server close to the servers of Italian stock exchange, yes. And this is a server part. And after we have also a client part that receives data from the servers, and the same client is used also for take data from cryptocurrency exchanges, because the platform is modular. You can switch different data providers, and you can add strategies like bots.
So when your platform trades cryptocurrencies, are they trading real cryptocurrencies or derivatives?
No, cryptocurrencies. We connect to. No, we connect to exchanges like Binance, Bitfinex, or 8BTC. We don't implement the parts like withdrawals or deposit, things like that. We just take public data like book all prices and last and trades, things like that. And we mix all together and trying to find opportunities. And so some parts are automated, and other need supervision about trader. And trader choose if the opportunity is good or not, and trade through and it trade using our platform and orders will be delivered to the right exchange and.
So it's more like to show the data, but
No.
execute everything outside of the platform.
No, we take the data from the exchange and we send orders to the exchange, everything via API. I don't know if if
buy and sell cryptocurrencies, you cannot cash out. In cryptocurrencies.
But we not use the platform is just is focused on trading. If I need to withdraw something, I just go on the exchange where I want to withdraw and I take out. The focus is trading.
So you connect it to the exchange, you go and buy stuff on the exchange itself, and the money is there.
Yeah. No, not with us.
But if I want to transfer it to myself, I can transfer it to my bank account.
Yeah, but from the exchange.
But it is something about exchange, not about our platform.
So remote controlling other platforms through your key.
Yes.
Only how to create
So we are using the same strategies we use in the traditional markets on the cryptocurrency exchange, something modified and updated because it's not the same.
If I'm using your tool, but it create multiple account exchanges.
Yeah.
All right.
You
I also need to have like a, I don't know, what is it? What is it?
Oh, like I say, we are a small company, so we add the exchanges very slowly.
All right. On top of an account in your tool.
Yes, you just go to Bitfinex. You create your account. You create public key and private key for the API, and just put in in our platform, and platform connects and start trading about. But you have to set up what you want to do.
Probably useful.
I don't know if I.
You're checking the best exchange rates. Is that the main?
So I select which exchanges I want to include, and then you basically take the data only from these exchanges and offer.
Yeah, sure. If you just want to use Bitfinex, you just use that.
I think the purpose of this is exchange normal cryptocurrency exchanges do not have good trading tools. The charts are not really good, hard to use, and sometimes you want to automate things. And these, like Bitfinex, the way to you can automate things is very limited. It's very small, so you probably more professional traders want more complicated tools to use, and that's what it's.
Exactly. Perfect.
So do you
Can you
code your strategy on the platform?
Can you code the strategy on your platform?
Sorry.
The platform can load strategies, but the strategy must be writing C++. And so we don't have a tool that you can put some, I don't know, some meta code and the platform transform the code in strategy. We think many times about that, but we never implement.
Some UI for this drag and drop strategies.
Yes, because the company is formed by half developers, so 3 developers and 3 traders plus something other. Okay, but so when a trader wants a new strategy, ask a developer to build for him, because with cryptocurrency we start to sell the platform also to customers, but before the platform was used just for us. We not sell anything. We just build platform and use for trading. The earning come from trading. So it's something work in progress. You not find too much on website because, like I say, before to start selling platform for cryptocurrencies, we just work for us. So we don't need to present too much to. But okay, the original company is Algebrica. The child company that focus on sell platform for cryptocurrencies and do other service about cryptos is called crypto360.it.
Like Italy.
Yeah.
It's like IT, not just Italy.
Yes. Okay. The less developed country about IT is Italy, I think, but it's called IT, yes.
Crypto360 IT.
Yes. I don't know what you can find on website because I don't care that part. I'm focused on develop trading platform. Yes, if you want to ask me more, I try to explain with my little English. Okay.
Good. We wrap it up. Thank you very much.
Oh,
I'm sorry to
you're
put you on the spot like this. This was maybe a bit rude. I'm sorry.
I know this happened.
Yeah.
Because you asked me many times.
Yeah, but it was.
I was sure about that.
So you were expecting a little bit. Okay, so thanks, people. Then let's wrap it up. And yeah, thanks for coming. And we can go and grab some food together if you feel like and continue the discussion. Yay. Bye bye, people from outside. Hee hee.